So good morning everybody, and this is the second part of the DDAY event, and the first talk of this morning should be given by Emanuel Federico Alsina, who is not here, he's not in Modena at the moment, he's abroad for his studies. So we will show a video.
Hi everyone, I'm Emanuele Alsina. I'm advised by the Professor Giacomo Cabri. Today I'll present the research activities that I made the last year. The purpose of my research is to build models and tools to manage the complexity in industrial and dynamics environments. So get started. My research activities can be divided in three different aspects. First of all, the artificial neural networks that I use in the maintenance field and to forecast the daily solar radiation in some places in Italy. The second aspect is the simulation of a manufacturing system. And at the end of the last year, I start to try to figure out how the diversity improved the performance of the groups. Alright, I want to split the aspect presented and explain a little bit in deep my research. So, starting with the neural networks, we use them to fit a curve called cumulative failure rate, and in the manufacturing field, starting from a series of failure rate that we can see here, artificial neural networks can be used to fit the cumulative failure rate of different mechanical components. In order to facilitate the use of neural networks by non-expert users in the manufacturing field, the idea was to use common networks and test the combination of different settings to define a sort of general indication for non-expert users. Changing field, we use also artificial neural networks to predict the mean daily solar radiation in Italian places. We collect a series of data of climatologic and positioning data, and we use them as input in a network to figure out the relation with the daily solar radiation. This is just an example. In our case, the output was just one, just the mean daily solar radiation. This case was different between the other one because in this case we optimized the network. We defined the best combination of number of neurons in the hidden layer. We also defined the best input which better forecast the daily radiation. It was very important. It was pretty important because we defined the relevance of the different input. At the end, I showed the result. They were considering another aspect of my research activities. We built a model to simulate manufacturing systems. With manufacturing system, we mean a set of sequential machines collocated in series or in parallel configuration to achieve a manufacturing process. They are production line. Examples include bottling facilities, textile plants, and car production line. The purpose of this research was to define the production rate as the average part produced per time unit of a certain manufacturing system considering its failure prone. To define this failure prone, we use different characteristics of the line of the machines, such as the aging, the degradation, number of repair, replacement, and preventive maintenance. And we didn't find in the literature a model which consider all these characteristics in the same model. We built an agent-based model system with different agents. One agent to define the behavior of the machine, one agent to manage the behavior of machine in parallel configuration, and one agent to define the rhythm of the production line. At the end of last year, I changed a little bit my research focus, and I try to figure out how the diversity, intended as a variation of some attributes, can be an important characteristic in the group performance. To understand this, we extrapolated data from a huge questions and answers website. We are defining, because it's a research in progress, different measures of diversity, success, and complexity. Complexity is necessary because maybe easy questions don't need diversity to find a good answer. On the other hand, complex questions maybe need diversity to be answered. And after that, we have to understand if it's true that diversity improves the performance of the group, and try to figure out how information technologies can be used to improve the group's performance. Last year, I attended a couple of international conferences. In the first one, I presented the simulation of the manufacturing system, and I just attended the second one to understand which models are common in the business field, and to meet people who work in this environment. I'm recording this video because currently I'm in the US. I'm in a research group at the Center for Complexity in Business at the University of Maryland. This group is led by Professor William Rand. Our research is about manage complex systems in the business environment, and our group is really diverse. There are mathematicians, statisticians, computer scientists, and also economic guys. And so I think the diversity improves the performance of our group, then maybe I'm in a good journey. I started my research period here last August, and I will be here until April 2015. These are our publications. The first one is a publication in a journal of manufacturing field, is the neural network approach in the cumulative failure distribution. that I presented before. The second one is the conference paper. It will be published in Computational Intelligence in Production and Logistics Systems. Is the simulation model of manufacturing system. And the other one is in submission for now, and is the artificial neural network to predict the daily solar radiation. So, what I will be the next year, I want to expand my studies concerning the reliability of mechanical components, maybe considering the use of sensory data. I would like to improve the model of the simulation model of manufacturing system in order to make it a tool for the decision-making process. And I will continue to research how the information technology can be used to improve the group's performance. And as I told you, I will continue my period abroad here in Maryland. And after that, I will spend a semester at the Information System Institute at the University of Southern California. That's all. Thank you for your attention. If you have any question or comment, feel free to send me an email or ask to Professor Crabtree, who should be in the room. Take care.
So thanks, Giacomo, for the video. And I don't know if there is any question about. Okay. Okay.
It's very interesting, your presentation and your activity, but you are in the United States till the end of your PhD. So after, do you think to come back to Italy, or are you waiting for a position in the United States?
So in my opinion, Emmanuel will come back to Italy. And his idea is to make something like a spin-off here about the ICT in industry. But I don't know, perhaps he has another period in California, and so perhaps he can find something interesting there.
So the next speaker this morning is Mr. Fabio Benedetti.
Yes. Ti chiesto computer. Come si fa a proiettare? È quella così. Ma mi apre.
Ci deve essere
Solito in progetto. Passato. C'è Adobe.
Non c'è per farlo partire direttamente dal menu.
Non c'è Adobe Reader. Lo sa per quanto? No.
Il mio era un video prima. partire la presentazione.
È un programma strano.
Ah, un PDF che dovete fare prima.
È sopra il programma lì. Fate per tutti.
Dovrebbe essere anche read mode, forse. Hai provato read mode? Dov'è? View? Read mode? Sì. No, già meglio. Già meglio, esattamente.
Ah, l'ho tagliata a me.
No, bisogna sì, rivedere magari la...
Good morning, my name is Fabio Benedetti, and the title of my presentation is LODEX, Schema Summarization and Automatic Sparkle Query Generation for Linked Open Data Sources. So the context of my presentation is the ecosystem of linked open data. This is the last version of the Linked Open Data Cloud. In the last few years, the number of dataset grows continuously. In fact, in the 2009, the dataset was just 300, while now are more than 1,000. This growth is driven by the open access trends that encourage the user in the publication of open data in the format of in form of linked data. But with this growth is not followed by tools and the techniques able to support the user in the discovery of sources of interest. The main issues in this context are that doesn't exist any standard in any standard way to document a dataset. The structure of RDF dataset can be understood only manually exploring the sources using Sparkle queries, and the semantic web technologies remain extremely complex for unskilled user. For this reason, I am developing a tool called LODEX. This tool aims to automatically extract and summarize a schema from a generic data set. This schema summary aims to support the user in the information extraction task, so in the building of Sparkle queries. This tool is online and totally automatic. In fact, works with Sparkle endpoint and doesn't require any additional information provided by the user. The schema summary aims have to describe a dataset, but a dataset in this field can contain a different kind of data. In fact, can contain ontologies or vocabularies or open data. So this is the architecture of LODEX. As you can see, is divided into main modules. The first is the extraction and summarization module that take as input the URL of a Sparkwell endpoint and extracts a set of indices called statistical indexes. These indexes are stored in a NoSQL database. After that, these indexes are taken in input by a post-processing phase that produces as output the schema summary. The second module is the visualization and query module that is implemented through a web application. This web application take as input the schema summary and provide to the user an interactive schema summary. The user can use this schema summary to build a basic query. This basic query is automatically compiled in a Sparkle query and can be sent, and it can be sent to the corresponding endpoint. So the first step is the index extraction process. This process extracts 9 different indexes divided in 3 groups according to the information that they represent. The 3 groups are general group, intentional group, and extensional group. The index extraction process is able to generate the Sparkle query that he needs to extract the statistical indexes, contain an iterative algorithm able to extract the intentional knowledge of the sources. It uses a technique called pattern strategy that can be used to decompose a complex Sparkle query in a higher number of less complex Sparkle query to overcome the issues of Sparkle endpoint with low performance. With the statistical indexes, we are able to generate a schema summary. The schema summary is composed by classes, properties, and attributes. On the left, there is an example of a representation of the schema summary. The nodes of the graphs are the classes. For each class, you can have an overview of its characteristics. In this case, the class is organization, and you can visualize the ingoing and outgoing property to other classes and the attributes. The second important feature is the Sparkle query generation features. With the web application of Lodex, the user is driven in the definition of a basic query. The web application contains also a refinement panel that can be used to refine the query. And this basic query and the schema summary is taken in input by a Sparkle compiler that produces output a Sparkle query. This query can be sent to the corresponding Sparkle endpoint, and the result can be visualized by the user with different view, tabular, maps, or different type of charts. This is a screenshot of the main panel of Lodex. In this box, there is the query built by the user. It contains 3 classes, and for each class, we have selected some attributes. This is the refinement panel, and on the bottom you can see the Sparkle query generated. With the panel on the top, you can modify this query. A demo of Lodex is online at this URL. And we performed different kinds of evaluation. First of all, we evaluated the performance of the index extraction process. We tested the system with more than 500 data sets. Of these, just 300 was reachable, and only 200 was Sparkle 1.1 compatible. And we completed extraction for 185 data sets. In the graph on the bottom, you can see the distribution of the time of extraction for this data set. As you can see, more than almost the 80% of the data set completed extraction in less than 500 seconds. We performed a different kind of evaluation, a user experience evaluation of Lodex. We take an online survey with 19 users. Half of these users was skilled user in the field of the semantic web, while the other half not. We divided the survey in 2 different parts. In the first part, we wanted to have feedback about the clarity of the browsing of the schema summary, and in the second part, we wanted to test the query generation features. In the table, there are some results of the task that we asked to complete to the user, and we get almost the 90% of current answers. As a future work, we are now modifying the interface of LODES according to the feedback of the online survey. We are planning to extend the void descriptor vocabulary in order to be able to publish the statistical indexes as linked open data. And we are planning to define some clustering techniques in order to reduce the size of the summary for huge data set. Here are my publication and activities, and that's it. I remain at your disposal for any questions.
Thanks for the presentation. Any question about this? Okay, thanks again. So we continue with the next presentation that will be given by Mr. Mario Bernabei on a completely different topic.
Good morning, I'm Mario Bernabei, and today we'll present to you the research activities of the past 2 years. The research topic of my PhD studies are high brightness solid state optical sources. My tutor is the professor Luigi Rovati and my co-tutor Giovanni Verzellesi. The research activities can be divided in two main groups. The first one is focused on the studies of the melanopsin and the annoyance of the human eye. Then the second group is more focused on industrial project with Silex Solar SRL and Egicon SRL. Let's start to speak about the main research activity. Then is focused on the study of the melanopsin and the annoyance of the human eye. About the melanopsin, we can say that this melanopsin is a photopigment generated by the ganglion cell that is a photoreceptor discovered about 14-15 years ago, and in the specific, the melanopsin is a photopigment that is able to inhibit the production of the melatonin that is directly acting on the regulation of the circadian rhythms of the body. It's also important to study the annoyance of the eye, referred to the power supply fluctuation and the quality of the drivers about the new solid state source. Since 2005, then after 2009 for European countries, and starting from 2007 in the US, the production of the incandescent bulb lamps is banned by the following following introduction of the new solid state sources. These sources bring some benefits, for example, high efficiency, energy efficiency, high lifetime, and the possibility of RGB color variation. These new solid state sources are introduced also in indoor and in outdoor environment. In the specific, we can see here, for example, in the office or in the house. Our goal is to study the effect of these new sources on the human eye, and for example, to study the annoyance that is probably caused by a periodic light fluctuation known as flicker, or color or intensity that act directly on the photoreceptors, the rod cones and ganglion cells. Then to quantify this annoyance, for example, we are studying the pupil area as index of stress. In the slide, also we can see that the solid state sources are, for example, the gallium nitride LEDs that have a big peak in the blue range that is in the same range of the sensitivity of the melanopsin that I spoke before. Then also we can have some sources, solid sources, RGB. So the eye is stimulated by 3 different colors. The actual normative are all based on the test made by the incandescent bulb sources, so they are obsolete. To perform these studies, we developed a new flicker meter, new system that it was presented the last year, but briefly we can have a look to the main blocks, the optical LED, the personal computer, and the control electronics. In this slide we can see the core of the system, the optical LED, where we can see all the active components and the passive components. Then on the right a diagram block of all the system. With the flicker meter we are able to stimulate the eye, for example. If we are doing a melanopsin test with 2 pulses, one in the blue range to stimulate the ganglion cells, then one with a red pulse to, let's say, erase the effect of the ganglion cells. To quantify the effect of the melanopsin, we define a new parameter, the pupil area contraction, that we can see the results in the following slide. And we can see, for example, that during the stimulation with the blue and the red pulse of 1 second in this area, the time of the contraction of the pupil is almost the same, but during the recovery time, so after the stimulus, we can see that after the blue stimulation, we have a sustained contraction. It means that the ganglion cell produce the melanopsin. With the same system, we can stimulate the eye of the patient to evaluate the annoyance of the human eye. In the specific, we propose this protocol, so we stimulate the eye with 6 different frequencies for each different color, for green, blue, and red. Also in this case, we define a new parameter, the pupil area, in function of the frequency to evaluate the effect of this stimulus. The results are shown in this slide. In the specific, we did an intra-subject test, so like 10, we proposed 10 times the same protocol to one subject. Then for the intra-subject test, we proposed the same protocol to 15 different subjects. As we can see in both the results, we have good contraction of the pupil in the low range if we stimulate the eye with the red stimulus. Then if we stimulate the eye with a blue stimulus, we have a contraction of high frequencies. Then about the green stimulation, we can see that the pupil is contracted around 8-10 Hertz. To conclude this first and main research activity, the results confirm the theory that are in line with the work published by other groups. The trend found due to the melanopsin is of interest to the sustainable lighting related to circadian rhythms. The maximum annoyance effect of the human eye, expressed by a minimum area of the pupil, occurred at 3 different frequencies depending on the chromatic coordinates, unlike what happened by using incandescent bulb sources that are obsolete. For the future development, we would like to test new protocols, modify the instrument to investigate different parts of retina, extend analysis to additional characteristic parameter of the LED light sources, study the performance and the physical characteristics also of the drivers for the new solid-state sources. Let's now have a look to the second group of research activity. In the specific for a research in industrial project with Silex Solar about the design of solar concentrators. Then with Egicon about the optical LCD characterization. As it was possible to see in the slide before, this activity, the research activity, was done in BrightLab. BrightLab is a laboratory born for the solid-state lighting characterization. In the specific, the characterization in thermal, mechanical, and spectroradiometric aspects of all the new solid-state light. For example, the gallium nitride. Then also the design and implementation of the driver of these sources. In the specific, with Egicon, we define a new protocol to calibrate a RGB camera in high definition for the optical characterization of an LCD automotive display. Then with the Silk Solar, I design and optimize the high efficiency mirror for the solar concentrators with optical CAD ZMAX. To conclude, a new custom camera calibration procedure is developed for a reliable optical characterization. Specific skills were acquired in optical design by using the CAD ZMAX. Then the collaboration with Silex Solar introduced a new research field focused on the triple junction, silicon junction used with the solar concentrators. For the future development, we would like to investigate the LED characteristic and behavior by changing physical parameters, then simulate the behavior of the specific LEDs and silicon chips by using the Centaurus simulator. Then this study focused on the commercial solid-state sources about optical and electrical characteristics to give an effort and to complete the research also with the melanopsin and the annoyance of the human eye. Then provide specific services to companies that require a full characterization of these new solid-state sources. These are the conference paper published and accepted, then the journal paper submitted. With this, thank you for your attention. I am available for any question.
Thank you very much for your talk. Any question? Okay, thanks again. The next speaker would be Mr. Luca Ferretti, but he's not here, so we will skip this presentation. So he's abroad, and he has decided not to give his talk. So no. We discussed this, but this was not possible to replace him in any possible way. So the next speaker is Mr. Carlo Augusto Grazia.
I'm in view. Yes. F11. I'm on view.
Read mode.
Okay.
Read mode.
Okay.
That's okay. No, that's okay. That's okay.
It's okay.
Thank you. I have the point. Yes. Sorry for the delay. Technical problem. Okay. I'm Carlo Augusto Grazia, a PhD student with Maurizio Casoni as a supervisor. And today I will talk about my last 2 years of PhD, my topic, which is scheduling and queuing for PPDR systems. And I will basically start by the description of the problem that we deal with the last 2 years, and the 2 main results, which are a packet scheduler and a buffer manager. And then I will go straight forward to the conclusions. So, what is the problem? We want to support the PPDR communications, and in order to do it, we want to provide high throughput and solution for save energy and improve fairness, quality of service, and also prevent attack, like denial of service or flooding technique. Why we consider this a problem? Because radio channels, which are massively used in PPDR systems, are unreliable by nature, and also because of they are deployed in a fast way. Let's say after a disaster event, they are unreliable more for this kind of reasons, and also the user itself cannot be reliable. We can have malicious users, and the disaster itself can be caused by users, by a real person, and not only by nature. Where we want to deal with this problem at the network layer, in fact, we provide two solutions, which are a packet scheduler and a buffer manager, which are both at the network layer of the TCP/IP stack. The scenario is really simple. This is a PPDR scenario in which a set of first responders, which are real persons, are connected through a MIOC, a mobile emergency operations center, through an external internet, an external web application, what you want. And the link between the MIOC and the external network could be several types of technologies. Could be a satellite one if the disaster involved everything in the field. It could be a point-to-point WiMAX. It could be an LTE. It depends. While surely between the MIOC and the first responders, the connection is a wireless one. And the scenario which we considered for the packet scheduler problem is the same described before, but we considered the downlink scenario, in which the MIOC acts as a router for the first responders and has continuously backlogged and has a lot of packets, and have to decide the order in which serve the first responder guys. And to do it, it can consider also the channel state information and the radio, the radio channel as it is configured in time. The typical solution is an integrated packet scheduler, which deal both with the quality of service problem and link characteristic one. So this is basically a weakness, because these two problems are placed at different TCP/IP stack layer. The quality of service problem is an IP level problem, while the link issues are MAC or physical layer problem. So we cannot use high packet scheduler for wired link for this scenario, because each time we want to change or modify the solution to boost the throughput or save energy, we have to modify again the packet scheduler. We propose a solution which is a modular approach, in which we have a double instance of a packet scheduler. The first one is placed as always at the quality of service layer, and we take the same structure and put it in a different and novel layer of the architecture, which we call MACSAL, which is MAC scheduling and abstraction layer, which is placed between the Internet Protocol layer and the MAC layer. And the purpose of the two scheduler is different, of course. The first one deal with the quality of service issues, and the second one deal with the channel state information one. And the benefits of this architecture are multiple. We basically can provide high quality of service guarantees using existing packet scheduler for wired link at the quality of service layer. So we can use the same packet scheduler for different technologies. And if we change something, we need to change only the second scheduler. So we can provide high throughput through cross-layering while still preserving flexibility. And moreover, we can provide the quality of service bounds of the entire scheduler, the entire modular one, by a function of the two theoretical bound provided by the other two packet scheduler, the one used at the quality of service level and the one used at the MACSAL level. We got a theorem that proves it. And we provide HFS, which is our packet scheduler, high throughut twin phase scheduler is his name. At the quality of service and the max SAL layer, we place the QFQ plus scheduler, which is an high performance packet scheduler developed here at the University of Modena, Reggio Emilia. And the main results are summarized in this slide. Basically, HFS provide a trade-off between throughput and quality of service, which is between a tunable parameter, which is Q, the buffer size used by the second scheduler, the MaxSAL1. And this is a tricky approach because in a same scenario, we can provide high throughput if we need to do it, or optimal quality of service guarantees. The red guy is HFS, while here the blue guy is the best packet scheduler in terms of quality of service guarantees, while the gray guy is the best integrated packet scheduler for wireless link. For what concerned the active queue management problem, the buffer problem, we considered this time an uplink scenario in which basically all the first responder are sending data through an external connections through the MIOC, of course, and at the MIOC level we are storing all the packets coming from the first responders, and we want to avoid some problems like a malicious user which try to flood the network and basically deny the service for the other ones. And we want to deal with the bandwidth problem because we also provide some centralized solutions for this scenario, which are not part of this topic, of this talk. And the typical solution for deal with this kind of problem is an active queue management, which is able to, of course, manage the buffer, the input buffer of a node. And the problem is that it's difficult to bound the bandwidth at the EP level because the bandwidth itself is it's something related to more related to the TCP layer, not the network one. So we have to move from packets to bandwidth. And we cannot use the packet scheduler as a solution in this environment because, yes, packet scheduler try to bound the bandwidth, but cannot deal with the queue side of the network. So we provide an active queue management technique, which is born for the centralized or cooperative networks, but provide a good result also in general purpose scenario. And it traces packets in order to obtain the round trip time by the hex, and infer, calculate the actual flow rate of a node. So, no, sorry, I skip a slide. Yes. The benefit of our solution, which is QRM, is queue rate management, is to give control about both the length of the queue and the bandwidth of the different flows inside the queue. It consumes a linear amount of memory, like all the buffer queue management available in the world. Has a time complexity which is, in a worst case, linear, but first of all, during the experiment, we see that basically it's always constant, and we are also providing a solution, a tricky solution, which is constant even in the worst case, example. And we also have a theorem that proves that the max queue length used by this solution is always upper bounded by the bandwidth delay product, which is a good result. So to summarize, with some plots, here we can see how 5 nodes act in a normal, let's say, error-free environment in which all nodes are sharing the external link in a fair way. In fact, all the nodes are, all the rate are clustered in the same line. And here is what's happened when an attacker tries to flood the network. He is stealing the bandwidth to the other nodes. In fact, here we have maybe 5 times the bandwidth of the other. And if we try to employ a standard active queue management solution like CODEL, control and delay, here we have the result. Of course, we can see that the attacker is, let's say, the effect of the attacker is mitigated, but also the other flows are compromised by the use of CODEL, and we completely lost the concept of fairness for the good nodes, and not the malicious one. Here is the result obtained with the QRM, which is able to mitigate the effects of the attacker, the red guy, but it do not change the behavior of the good nodes, which remains fair in the network. At the same time, QRM is able to reduce the queue usage, the queue occupancy level, and maintain a stable round trip time, which is the green guy, during the simulation. Here we have the same scenario in which we use the tail drop technique to see how much the queue level and the round trip time change during time. So that's all. To conclude, we provide 2 solutions, a packet scheduler and an active queue management technique. The packet scheduler is a novel modular packet scheduler. It has a higher throughput than the best integrated packet scheduler available in the literature. It has also an optimal quality of service guarantees with an execution time close to the deficit round robin 1. And with this low execution time coupled with the high throughput, so the decrease of retransmission, we can also say that this packet scheduler is good for energy consumption point of view. The buffer management QRM is a novel timestamp based active queue management. It can infer the bound and bound the flow rate of a node. It's efficient. It can insulate a traffic coming from a node. It's also efficient in terms of memory usage, and also the runtime complexity is constant. So that's all. Here is a list of my journal and magazine papers, both accepted and submitted. And here is a list of the conference and workshops one. So that's definitely all. Here's the last slide, so thank you for the attention. If you have any kind of question, feel free to ask.
Thank you very much for your talk. Any question? Okay, we have a couple of questions.
I have one question. How do you detect malicious nodes? And the other question is, do you think, are you thinking about some technique to select, to filter packets? Because many agents may send... Yes, the second is more semantic. The first is... yes.
The second is easy because it is not... can I have the... Sorry. The second one is easy because we do it. So we have a table which allow the user to send. So all the outsider user cannot at all send something through the emergency network. So the second problem is already solved. For the first one, which I don't remember well, what was the question?
The second is not solved, but in any case, the first one is how do you detect malicious?
Okay, sorry. We are in a cooperative and centralized environment, so we immediately can infer through the bandwidth. We infer if a node is exceeding the allowed rate. So if you exceeded it, you are not part of the cooperative environment. Okay.
So do you have to modify the operating system in order to apply your technique? Perhaps I missed it.
Yes, because the algorithm QRM is not part of, let's say, Linux, so we have to add it.
Okay, do you think that it can be done in a modular way or in a simple way, or it requires a deep modification of the whole operating system?
In the NS3 simulator, which is quite similar to the Linux implementation. So I think that is quite free, the implementation in a real environment.
Okay. Thank you very much again. So we have the next talk that will be given by Mr. Martino Lombardi. Okay.
Good morning, everyone. I'm Martino Lombardi. My tutor is Professor Rita Cucchiara, and the title of the presentation is COP Model-Based Processing of Sensing Floor Data for Human-Computer Interaction. Following the Internet of Everything trend, several general-purpose devices have been proposed to acquire information from environment and from people interacting with it. And among the others, sensing floors have recently attracted the interest of the research community, thanks to the possibility to, starting from these kind of systems, to produce a plethora of applications spanning from entertainment to security. The topic of my research activity is the development of a sensing floor for human behavior analysis, and during the first year, with the collaboration of the Image Lab group of the University of Modena and Reggio Emilia, and with Florium Ceramiche SPA, a company of Fiorano Modenese, we designed and developed an innovative sensing floor called the Floor Image System, that is able to detect people presence and movement. During the second year, we used the information, the spatial temporal information from floor image system, to test the possibility to extract spatio-temporal descriptors to classify some behaviors of human on the sensing floor. These 2 points were the object of the last DDAY presentation, and are more detailed in the poster that I invite you to visit during the break. So today I want to speak about my last research activity that regards the development of a data analysis model that not assume a regular grid distribution of the sensors below a sensing floor, and is based on the concept of the center of pressure that is widely used in biomechanics. The COP model is alternative to the pressure image model that is the preeminent approach to the problem. The basic assumption of the pressure image model is that the pressure applied on top of each sensing element is related to a pixel of an image. So at each sampling time, a sensing floor generates a sort of pressure image where each pixel corresponds to a spatial portion of the sensing floor, and the pixel value is related with the pressure exerted on the top of the sensor. Despite its simplicity, this approach has some advantages, such, for example, the possibility to use common video processing and analysis techniques on a collection of consecutive temporal pressure images from the sensing floors that can be seen like a sort of video pressures of the floor. But some drawbacks, this kind of approach has some drawbacks, as for example the impossibility to use this approach when we have a non-regular distribution of the sensors below a sensing floor. For this reason, we tried an alternative approach to the problem, and we well know that in gate postural analysis, the use of force platforms made of, for example, piezoelectric sensors is a common practice. And thanks to these measuring platforms, kinesiologists can evaluate the ground reaction force and the center of pressure of a person standing or moving on the platform, where the ground reaction force is the vector sum of the normal components of the forces exerted on the top of the measuring platform, and the center of pressure is the point location of the ground reaction force vector and represents the weighted average of all the pressures over the surface of the area in contact with the measuring platform. So, considering a regular or a not regular distribution of the sensors element of the sensing floor, the whole area covered by the set of sensors can be partitioned into convex polygonal shells that have the sensors as vertices, and the type of polygonal polygonal decomposition is strictly related with the sensors layout, and with the space resolution of the sensors disposed on the sensing floor. But if we consider a regular grid distribution, such as in the right side of the slide, we can use shells of a rectangular shape. Hereinafter we will call these shells floor cells, and for each floor cell FCE, we have a 3D state point PE, and its coordinates are these. And the first two coordinates are the center of pressure, and the third is the intensity of the ground reaction force related with the sensors of the specific floor cell considered. At each time t, a floor cell can be considered in an excited state if the equilibrium conditions occur, where TH is a threshold specific for the application and can be used to remove the noise contribution, and the left member of the question is the Euclidean distance between the 3D state point P at time t and 3D state point in an equilibrium condition considered when no people, no weight were on the sensing floor, and NE is a matrix, normalization matrix that consider the shapes, the particular shapes used for the floor shell, for the definition of the floor shell. So at each when a person is on the floor cell, more than one floor cell can be in an excited state. If we consider cluster of floor shells excited, we can consider the cluster CJ as a detection of the presence of a person on the floor. And the two coordinates BXJ and BYJ are the position of the cluster on the floor. So each cluster is a detection that can be associated to a track simply using a nearest neighbor algorithm, for example, to perform a tracking algorithm on using this new approach. So to evaluate this kind of tracking algorithm, we used the experimental setup in the slide, where we can see a Kinect and a floor image system that are set to work in a synchronous way with an acquisition rate of 10 Hertz. And we have been exploited the people tracking capabilities of the Kinect to obtain a ground truth to evaluate the tracking algorithm proposed with used with the floor image system. In the tables, we can see we collected 6 data sequences of walking people involving from 1 to 7 individuals with different weights, and we evaluated the performance of the algorithm in terms of precision and accuracy, using the data from the Kinect as ground truth. The results are very promising, even if we compare them with the results obtained with the same sequences with a tracking algorithm derived from the pressure image model. So, in conclusion, we proposed a new data model to perform to process the information acquired by sensing floor that not strictly required the regular distribution of the sensors, and several tests on real sensing floor prototype confirmed the validity of the model and the outperforming capabilities on people detecting and tracking. Thank you.
Thank you for the presentation. Any question about? Okay, thanks again. We continue with the next presentation that will be given by Daniel Magalotti.
Good morning, I am Daniel Magalotti. I'm going to show you the research activity on my second year of the PhD. In this presentation, I'll give you a brief introduction. Then I describe the wireless sensor network application with particular attention to the sensor node optimization. Then we move to see some experimental characterization of the system, and finally the conclusion and the scientific publications. The topic of my research can be classified under the healthcare monitoring application. In literature, there is a lot of systems that are developed to monitoring the health status condition of the patients. All these systems can remote and continuously monitoring the health condition. The information of the health status condition can be accessed anytime and anywhere without also restrict the movement of the patient. Arising from this system, we focus our attention on the medical side operator. And our goal is to improve and use all this technology to improve the safety and control standard of the medical operator, where during their work are exposed to a health risk. So the goal is to design a portable system to monitoring the absorbed dose of the medical operator during interventional radiology procedure. This system is based on a commercial CMOS image sensor. This system improves the performances to measure the X-ray field and to improve the characteristic of the actual personal sensor dosimeter. And here we can see I highlighted some characteristic of the system. Is wireless, has onboard processing, and is low power, and so on. So this is the monitoring working scenario. We are inside an operating room during an interventional radiology procedure. The operator uses an X-ray tube to obtain image guidance. So the X-ray radiation is scattered from the patient and is absorbed by the operator. So in this context, we design a wireless sensor network that consists of a remote terminal with a receiver connected to a remote station, and more than one personal sensor node that are worn by the operator. The personal sensor node consists of a sensor, an image sensor, and a digital signal processing unit that extracts two observables correlated to dosimetric quantities. In the network, we implemented a TDM, time division multiple access, in order to don't overlap the transmission of the different sensors to the receiver, to the remote terminal. Focusing on the sensor node, during the first year, a second version of the prototype has been designed and characterized in laboratory with the aim to optimize the power consumption. So in this table, we can see that we have optimized the power consumption of the system. During this year, we focus on the portability. In particular, we focus on the RF interface, on the wireless interface, by using a compact solution for the antenna. The dipole antenna has been replaced by a chip antenna that has very small dimension, and the chip antenna is working in the same frequency range. The antenna has been simulated in order to evaluate the effect of the human body on the antenna performances. So first, the antenna has been modeled by using an electromagnetic simulator, and also an equivalent body has been modeled with the parameter C in this figure. So two kinds of simulation we performed. The first, we simulate the antenna without a body. We can see that the frequency range, the frequency working point is very near to the target of working frequency point, and is due to the fact that we don't know exactly the model of the antenna. But what we are interested in is the relative frequency shift when the body is very close to the antenna. Here we can see that when the body is more than 1.5 centimeter, the frequency matching point is not affected by the human body. After, a test board has been designed to measure the performance of the antenna. This is the test board, the hand. So we can see in this table that the simulation are validated. There is a little bit difference, but we can model exactly the hand of the operator, so the body. But from this figure, we can see the reflection coefficient, and the reflection coefficient is acceptable when the distance between the human body and the antenna is greater than 1.5 centimeter, because the reflection coefficient is under minus 10 dBm. So after we measure the performances of the system by considering the wireless loss, and we measure the packet error rate. First, the comparison of the system with the dipole antenna and the chip antenna has been performed in open space. The range distance covers the typical dimension of an operating room, and we can see that the chip antenna can be used in this application because the performances of the system with the two antennas is comparable. Then we move inside an operating room, and the two different acquisitions have been performed with the receiver outside the operating room and with the receiver inside the operating room. We can see there is a lot of difference in the packet error rate when the receiver is outside the operating room, and is due to the wall of the operating room. And so for the next acquisition that is done during medical procedure, we placed the receiver inside the operating room, and the medical operator warned the sensor, two sensors that are the same family, acquired with the on-shelf acquisition board that is wired, and with the prototype. In this table, we can see that the packet error rate confirm the packet error rate found when there is no medical operator. And finally, we focus on one procedure. The observable correlated to the dosimetric quantities has been extracted with the two different systems. And we study the time correlation of the different peak that is due to the pulsed regime is the typical regime of the X-ray tube. And we can see that the two systems are correlated in time. And there is a difference on the amplitude of the observable extracted by the two systems, and it's due to the geometrical position of the medical operator with respect to the X-ray tube and the patient. Okay, during this year I also spent 3 months at the University of Geneva. During this period I optimized a processing unit that is used for track selecting in the high energy physics experiment. Starting from a processing unit that consists of 2 different boards, I designed a new mezzanine card that is just one card, and also all the functionality will be implemented in one more powerful FPGA. Okay, in conclusion, I described the implementation of the wireless sensor network, focusing on the optimization on the sensor node for the power consumption and portability. Then we performed some measurement of the wireless loss in open space and operating room. As future work, we want to design a new version of the prototype that integrates all the functionality inside a single board, and also will be optimized for the dimension. And the node have to be characterized when more than one personal sensor node operates simultaneously, and we want to compare the performance with passive dosimeters that are currently used in the interventional radiology procedure. Here there are the scientific publications, journals, and the international conferences. That's all. Thank you.
Thanks for your talk. So, any question? Okay, thanks again. The next speaker is Mr. Giacomo Antonio Napoletano. So, maybe I don't remember his. Okay, he's not here. Laura Natali. Okay.
Good morning, I'm Laura Natali and my tutor is Professor Maria Luisa Merani. I'm going to present you the research work carried out in the last year, a novel rate control strategy for adaptive video streaming in peer-to-peer overlay. Nowadays, we witness to an explosive diffusion of IP video traffic, and end users consuming video employ different devices, ranging from smartphones to tablets and PCs. And they experience different network conditions on the basis of their location, at home, in office, or on the road, for example. Recently, to cope with heterogeneous users' requests and bandwidth fluctuations, a new delivery streaming framework has been introduced, DASH, which stands for Dynamic Adaptive Streaming over HTTP. Most of the research work dealing with DASH examine client-server scenario. Differently, I proposed to combine DASH technology to a pure peer-to-peer architecture, in a new peer-to-peer dash system. The term pure indicates that the server contribution is minimal, that is, the video diffusion is relies upon the cooperation of peers. Dash technology provides for different representation of the same video. Each of them has a different resolution and accordingly a different streaming rates. Dash clients dynamically switch from one representation to another. A pure peer-to-peer system consists of n nodes with heterogeneous upload capacities that cooperate in order to distribute a single TV channel. And that is, they share the video chunks it owns with other peers. A new peer-to-peer dash system is a multi-overlay architecture where there are k overlays, as many as dash representation. At each overlay corresponds a different streaming rate. And without loss of generality, the streaming rate of overlay J is higher than the streaming rate of overlay J minus 1. Each peer in peer-to-peer system are dash clients, and each of them is characterized by a desired representation that correspond to the max resolution representation that it can play out, depending on the device feature and capacity connection. Every dash client starts from the lowest representation and gradually migrate from one overlay to another in order to reach the desired one. The switching control algorithm that I proposed has two distinct objectives. First, considering node perspective to reach the desired overlay, and second, considering system perspective to reach a steady state and accommodate as many users as possible. So generic peer monitors local and global indicators. As local parameter, I choose delivery ratio and request window status that provide an indication about viewing quality of a generic peer I. As global parameter, I use the instantaneous resource index of overlay J, that is a static balance of upload and download resources in the overlay at the time t. The second parameter, instantaneous efficiency, tells us the actual capability of the overlay to serve its all members. They are indicator of the overlay hold status. Local parameters govern the switch down process, and the global parameters govern the switch up process. Here I illustrate you the switching control algorithm proposed. Every delta t seconds, the generic node I within the overlay J verifies its satisfaction. Not that a node I is satisfied if it can watch the video at the desired streaming rate. If the node I is not satisfied, is verify the possibility to switching up to the overlay J+1. If this overlay is in good condition, then it switches up. Otherwise, it controls the video quality experience in the current overlay. If both local indicators are below the minimum thresholds, then the quality is not good, so the nodes scales down to the overlay J-1. Otherwise, it remains in the current overlay. Well, I wonder how good is the switching control algorithm that I proposed. That is, what is the global satisfaction that the algorithm attains? And is there a maximum satisfaction level to compare against? If so, how far is the devised algorithm from the optimum? Well, in static conditions, we have n nodes to be distributed in k overlays, subject to certain bandwidth constraints. So I formulate an integer linear programming model, and its solution provides an upper bound to compare our approach against. Quickly, let's look at the ILP model. There are n nodes and k overlays, and I define a satisfaction function that is equal to 1 if the node I is assigned to the desired overlay 0 otherwise. R sub j is the streaming rate of a generic overlay j, and the objective function of the model is to maximize the overall node satisfaction, and it is subject to the following constraints. First, the bandwidth constraints, that is the overall upload capacity within the overlay J must be greater than the overall download requirement. The second constraint guarantees that each node is assigned to one overlay only. The ILP model represents a simplified peer-to-peer dash system. Indeed, it doesn't consider the dynamicity of a real system where peers join and leave at any time. I developed an event-driven simulator to replicate the peer-to-peer dash system with 2,000 nodes distributed in 4 different overlays. The nodes interarrival time and session times are exponentially modeled, and as I earlier mentioned, the server contribution is minimal. Heterogeneous user bandwidth profile are shown in the table, as well as their streaming rate of the dash representation. I investigate the system behavior in 3 different scenarios. Conservative scenario, where every peer wishes to stream the highest representation whose bit rate is lower than the peer's upload capacity. Uniform scenario, where every peer uniformly selects the desired representation from the 4 available ones. And aggressive scenario, where every peer wishes to stream the highest representation whose bit rate is lower than the peer's download capacity. Here are some results. This graph indicates the nodes distribution in the 3 different scenarios. As you can observe, the system quickly reaches steady state in conservative and uniform scenario, while about aggressive scenario, it takes longer for the system to reach steady state. On the other hand, this is a critical scenario where it is not possible to serve all users' requests. And so not all peers can be placed in the desired overlay, but they must be reallocated. Here I compare the system satisfaction of peer-to-peer dash system obtained by simulation to the ILP upper bound. The value of system satisfaction are normalized by the number of the peers in the system. So if all peers are satisfied, the system satisfaction is 1. The model tells us that only in conservative scenario is possible to serve all users' requests. But in uniform and aggressive case, it's not possible. The bandwidth constraints limit the number of nodes that can be satisfied. The satisfaction value obtained by simulation, the blue bars, are very close to the optimal values provided by the model. You can see the red bars. At last, I compare the proposed system, peer-to-peer dash system, to a peer-to-peer system made of isolated overlays. as many as the desired streaming rate. In this system, nodes cannot support dash features. That is, they cannot move among overlays. Also, not all peer can be placed in desired overlays. Peer-to-peer dash guarantees a better video quality under the same users, the same streaming requests, and the same system resources. As you can see, observing the delivery ratio and playback delay values. In conclusion, the new peer-to-peer dash architecture that I proposed is able to guarantee as many users as possible a very good viewing experience, and is able to guarantee Swarm to reach a stable operating condition with no contribution of an external server. In the near future, I will introduce further performance metrics and will investigate system stability in the presence of flash crowds, in order to gradually perfect the switching control algorithm and to fully demonstrate its effectiveness. Thank you for your attention.
Thank you very much. Any question? Okay, we can. Thanks again. The next speaker is Mr. Lorenzo Racchetti.
Hi everyone, I'm Lorenzo Racchetti and my tutors are Luigi Biagiotti and Cesare Fantuzzi, and I'd like to speak to you about my last year research activities on object-oriented programming in automation and dealing with multi-scan operation. So first of all, what are multi-scan operation? Are operation on in the PLC world that take multiple PLC scan to operate. So which means that they are called, they are invoked in a PLC scan and then live through all the PLC scan just until they operate and finish what they have to do. So why focusing on multi-scan operation? Because they are pretty common in automation. For example, homing, you have an axis that has to move until you reach a certain position which is considered as home, or for example for positioning. And they are hard to handle as they live through the PLC scan, and they are a bit opposite of the way of the PLC cycling way of doing things, that you call something, you do something that lives only in that scan. So they must be kept alive while the PLC is cycling, and it is required so to track their history and their evolution to operate. So, which is actually the current situation in industrial automation. They use most of all rule-based languages, for example, ladder logic. I think many of you, if have any know about PLC, know ladder. And they just do a set of rules, which all the conditions for the several cases of the evolution, and they keep track of this evolution by looking at which rule is satisfied. So a rule is satisfied if all the conditions of that rule are satisfied, and then they act their active behavior of the operation through this satisfied rule. However, this approach is a bit too rigid, because if you have to do some edit, some change while you are coding, while you are running your test and your machine, you have to take into account all the condition and all the set of condition that makes the rule, and so it's not so flexible, let's say. And moreover, the testing is really hard because you have many rules that can be also satisfied at the same time, and this is not nice even. And moreover, the validation must be done after the whole implementation of the plant. So what is our proposal is to use modern engineering principle to define directive behavior as a set of states and connected via transitions, which is just a state machine. We will use UML state chart that are an announcement of classical state machines. And moreover, we will also would like to use object-oriented programming to reduce life cycle and provide tested and verified, validated object to the system engineers to be deployed, so it will reduce life cycle, as I said. And also, the nice thing of object-oriented is that to extend this object provided, it is not necessary to retest and validate the old things, but just you need only to test and verify, validate the new thing that you has added. So, is it possible to use object-oriented in PLC? Recently, there was the IEC 61131, which is an open standard, and the third party introduced some object-oriented extension, which does not cover all the object-oriented feature of computer science, but most of them. And so, using those object-oriented extension, we developed a design pattern, which provide actually a core library that can be used to implement all the UML state chart, and so all the MSO that you want to define as UML state chart. And also the design pattern, the library is object-oriented, so which means that it can be extended to add new features that also differ from the UML standard. And so it is mainly based on states. This is a function block, which is actually a generic state with all the functions that can be used for define the action in that case, in the evolution of the operation or state machine. And also another function block, which is actually the state machine, which is kept alive through the PLC scans by the spin method, which keep tracks of the evolution through the states and through the transition with the conditioning. So, for example, if we have an MSO which can be defined with that UML state chart, we can describe the actual code implementation on the PLC through a UML class diagram, which is that one. So we can see that this is actually the UML state chart, and we have also an attribute state for each state that actually was defined in the UML state chart. And we have also a function block handler related to each state that defines the action that should be taken during when the state is alive, is active on the state machine. So here we have lastly the mapping from the UML class diagram to the actual code on the PLC, and that's all. Maybe a bit too fast, but so concluding. We used modern engineering principle to define MSO as a UML state chart. We also used object-oriented design pattern to reduce the life cycle of MSOs. We also presented part of that work on international conference, ETFA, in Barcelona. And so perspective for this year, actually, are to exploit the object-oriented features for outdoor section mechanism, which means you have on the same machine a device that can be changed, and it does not depend by the provider, which means that, for example, if you have an axis provided by Beckhoff, the code on the PLC will not change if you change the device with a Siemens axis and so on. Moreover, we would like to investigate on automatic generation of documentation from the PLC code, because we found that it is actually really hard to keep the documentation of your code aligned with the code, which means that if you are running something or doing some test, and then you find a bug or something that does not work as you intended, then you do a change, but unfortunately, usually, you don't keep track of that on documentation. So which means that if you have some problem and you have another person that have to be kept updated, he must look at the code and not at the documentation, so the documentation became more unusable, let's say. Moreover, we would like to investigate on unit testing, because we spoke about providing something that is tested and validated, but we have done that in a manual way, and we would like to investigate if it is possible to do in a more automated way, like in computer science. So, I finished. Thank you for your attention.
Thanks a lot. Any question about these issues? Okay, thanks again. So we have the last two talks. The first one will be given by Giovanni Simonini. Oh, okay.
Okay. Good morning, I'm Giovanni Simonini. During this presentation, I'm going to talk about my research activities for the past year that was focused on the definition of a statistical approach to discovering the topics of data sources. And first, let me introduce the problem, saying that the semantic web vision is now a reality. In fact, thanks to many technologies and standards like RDF or Sparkle, now the web is moving from the web of document towards the web of data. This is in fact true because thanks to these technologies, we are able to reuse and make interoperability with data. In fact, we are not surprised to see that many enterprises and governments are now publishing their data in this so-called linked open data format. And moreover, there are many techniques and tools that has been developed to analyze in an easily way, also for non-expert and use and extract value from this data. But an open problem, an important open problem of this field of research is answering this question. How to find data sourcing satisfying some specific needs, information needs, and the solution is not trivial because a classical search engine cannot be adapted to this scenario easily because they are not conceived for indexing structured data. And moreover, generally, these open linked data sources are provided with metadata given by the data source owner. And the quality is not guaranteed, and it's often difficult to exploit them in a correct manner. For this reason, searching in portals with those search engines can be a tedious and error-prone work that can generate as a result if the metadata are not accurately selected. So my proposal is to provide an automatic data-driven approach to extract metadata from a target data source. And moreover, handling also the use size of the involved data. My approach relies on three key elements. The first, reference ontology, that is used to find the topics. In this case, we exploit DBpedia, that is the RDF translation of Wikipedia, so is a vocabulary that can model the world domain with more than 600 concepts. And the second key element is a signature. I propose a model that can be used to extract a signature to describe each data source and match it with the ontology through the matching algorithm, and so to find out the topics of the data source. I have to make two main hypotheses. First, no notion of semantic is involved in this process because with the semantic I mean exploiting the semantic of name, of concept, and relation of the data sources. This surely can improve the match, but here I want to demonstrate that we can exploit only analyzing, we can match the data source with the reference ontology, only exploiting the data distribution and not the semantics. So this is an orthogonal problem. Another orthogonal problem is the one-to-many, many-to-many match. I mean, in my approach, I only consider the match from a class of the data source with only one class of the reference ontology. The models can be used for the one-to-many, many-to-many match, but to demonstrate that it can work, I've done this hypothesis here. And the model, we can see here above a fragment of the RDF schema of the class person of DBpedia, and below the total dependency graph built with my model. In the RDF schema, we have one only kind of node, and edges can be properties that are translated in two kinds of node in the total dependency graph. In fact, node can be either concept or properties, and we have three kinds of edges. Two directed edges that going from concept to properties and from properties to concept, and indirect edges that represent a relationship among properties inside a concept. So we can use this representation to build the graph and weight it and use as a signature. To weight the graph for the node, we compute the entropy of the value of the properties of each property of the concept, and for weighting the undirected edges among properties, we compute the mutual information. So this value can somehow capture the correlation of the property inside the concept. During the experiment, I also find out that, in particular for this domain, exploiting classical mutual information can be very sensitive to small probabilities. In particular, can produce some unstable result. So I employ also well-known technique based on the composite likelihood model to smooth this behavior and introduce weights that can limitate the effect of small probability. So here some results. I try to match a class, so I say the one-to-one matching, but I also try to match subclasses because DBpedia has a hierarchical structure. So I find out that also there's a similarity between subclasses and classes, and we have demonstrated that exploiting the composite likelihood, we can obtain a more polarized value. And moreover, an interesting result is that we have found out that we can use only entropy, that is easier to compute than mutual information that involve all possible combination of properties. And so this result allow to exploit mutual information only when we have uncertainty. So is further step of optimization, and we can separate the two steps, and the computation became easier. So now I'm working on the testing of 3 different techniques to estimate entropy and motor information, in particular to select the weight for the different component. And I'm carrying on a comprehensive experiment on DBpedia, and I'm working on the algorithm for the one-to-many, many-to-many matching. As a future work, in particular this year, I'm going to work on the scalability of this method, because often with these data sources, size has millions of instances, hundreds of concepts, and hundreds of properties for concepts are usual. So porting this model to a distributed system like Spark for the big data analysis can be very useful. In particular, I'm moving towards the entity resolution problem in this big data scenario. So these are project and activities that I participate this year, and the accepted publication. So, thanks for the attention.
Thanks for your talk. Any question? Okay, thanks again. We have the last speaker of this cycle. Then we will have 4 speakers of the 29th cycle. So, Mr. Matteo Sola.
Good morning, I'm Matteo Sola. The title of my presentation is Demand-Side Management in a Smart Microgrid, a Distributed Approach Based on Bayesian Game Theory. And my tutor is Professor Vitetta. After a brief introduction about the smart grid model, I will talk about the demand-side management algorithm that we developed, and finally I will show some numerical results. Here there is the microgrid model that we considered. There are n prosumers that are users that can both provide and require energy from the microgrid. Each user is equipped with an electric gateway that can collect information about the power consumptions. And there are also some loads that can be unshiftable loads that has to be scheduled in a specific time of the day, and some shiftable loads that can be scheduled in a proper manner. There are always some renewable energy sources. And the microgrid interfaces with the public utility by means of a utility interface that supervises the prosumers and interacts with the electric gateways of each user. So in our work, a novel demand-side management strategy is developed, and it aims at matching load demand to power supply. This result is achieved by scheduling shiftable appliances in a proper way. In the literature, there are other works about the scheduling and the distributed and autonomous strategies, but in all these works, the availability of some form of information to all the users is fundamental. Instead, we think that preserving the prosumer privacy is an important feature, so we used statistical information about the user instead of the real data. Here there are the information flowing into the microgrid. In particular, the unit interface knows the first order probability density function of the overall power, and the electric gateways of each user knows the instance at which the user would turn on its shiftable loads and the power consumption these activations would entail. So the unit interface has a prediction of the overall power based on past data and weather forecasts. Instead, the electric gateways knows a prediction of the power of each of the single user and does the DSM strategy. So a user that wants to activate a load, for example, in an electric vehicle, send an activation request to his electric gateway. So the electric gateway faces an activation dilemma. He can satisfy the request or he can reject it, and in this second case, the shiftable load activation is postponed to the next interval. So a player is seen as a selfish player that plays against the other players of the other users of the community, and the other users are seen as a fictitious opponent. So we are in front of a two-player game. The action set of a user is composed by two actions. He can turn the shiftable load on, and in this case the payoff will be equal to EP, or he can keep the load off, and in this case the payoff will be equal to 0. So the evaluation of the payoff requires the introduction of a pricing model. So we introduced a cost function that depends on the power of the single user and the power of the other users. There are no details in this presentation about this function for the limited time, but it is important to underline that this function is negative if it represents a cost for the user, and it is positive if it represents a reward. So the expected overall cost in the considered time interval is evaluated with this expression where there is an integration over the time of a function that depends on the cost function and on the power of the single user. And the expected payoff is the difference between the expected cost in the case in which the user decides to turn the shiftable load on and the case in which it keeps it off. So the optimal strategy is to find the activation instant in which the user obtains the maximum value of the expected payoff function. but we decided to not adopt this optimal strategy for different reasons. Instead, we used a mixed strategy. In this mixed strategy, player one repeats the game until he opts for the on action or the maximum number of attempts is reached. The selection of a specific action in the given action set, so on or off, is randomized. So is like to have an unfair coin flip. A face of the coin represents the on action and it is associated with the activation probability. Instead, the other face represent the off action. The PS instead represents the probability of a success in kn attempts for the nth user. So our mixed strategy aim at adjusting the probabilities in a way that the reduction in the expected cost is minimized on the average over the set of the prosumers. So this probability isn't a constant value, but it is updated in every time interval based on the statistical information that the user receive. We did some numerical simulations considering a microgrid with 100 users. Each user has a 6 kilowatt contract of power and it can generate up to 3 kilowatt. Each user has an electric vehicle and other 15 home appliances, and we considered 3 consecutive days for the simulations, concentrating in the second days all the electric vehicles ignitions. In this picture, there is in blue curve the microgrid overall power, and in red curve the absorbed power from only the electric vehicles. We can see that with the algorithm that we proposed, the peak of the consumption is smoothed. Here there are the probability density function of the percentage improvement in the microgrid par with the proposed strategy, and the average percentage improvement is about 34%. So in conclusion, a distributed DSM strategy relying on statistical information about the consumption and the prosumer consumption and the overall consumption has been developed. The proposed strategy allows to schedule shiftable loads in order to mitigate the PAR while substantially preserving user privacy. Numerical results evidence a significant reduction in the microgrid PAR. Thank you for your attention.
Thank you. Any question? Okay, so the presentations of the 28th cycle are over, and so we have now 4 speakers of the 29th cycle, and the first one is Mr. Lorenzo Albano. A mezzogiorno. può fare anche adesso. Oh, sì, lo faccio anche dopo, sì, alla prossima presentazione.
Good morning. I'm Lorenzo Albano, and I would like to start with a brief background in order to introduce the work on which I spent most of my time this year. And this is the identification of the meaning of words, of ambiguous words in a context. This is a real difficult problem, and it gets most interest from the research community. Because it has been proved that the use of meanings instead of simple words can improve the performance of many computational tasks such as information retrieval, data integration, machine translation, or intelligent web search. To this problem, in literature, have been proposed two solutions, the word sense disambiguation and the word sense induction. The word sense disambiguation is focused on how to select the most suitable word sense from a sense inventory. And it reached the state-of-art word sense disambiguation algorithm reaches very good performance. The problem of these techniques are that they need a sense inventory, so such as WordNet, this sense inventory are very difficult to update and difficult. They are very they offer very cost to update and to maintain. So there is, and moreover, there is the need to manually annotate training data. So in recent years, word sense induction techniques have been proposed. These techniques are focused on clustering word occurrences depending on their meanings. They are techniques based on distributional hypothesis, so that is the hypothesis that a word expressed with a specific meaning can tend to co-occur with the same words. These techniques have no need of sense inventory or manually annotated training data, but in terms of performance, they does not reach the state-of-art word sense disambiguation algorithm. A word sense induction task is a two-stage process. The first step is the context representations, that is the way we can represent an occurrence of word. Typically, they are represented as a context vector that is in their simplest form are a set of words. The second step is the context clustering. That is the clustering of the context vector depending on the sense the word is assuming. As I said before, the real problem of word sense induction algorithm is the lack of performance respect to word sense disambiguation techniques. So we try to resolve this problem by using a multilingual context representation in order to achieve better performance. With a multilingual context representation, we for each word, for each context in which a word occurs, we consider its translation in different languages. This should give a twofold improvement. The first is the obvious enrichment of the feature space. Simply, we have more words to consider in order to distinguish between senses. And the second one is the improvement on the quality of the context representation, since we are taking the more information from the translation process, we are putting it in our system. This can be seen in this example, where example where we have the word plant expressed in English and its translation in Italian. In the first and third sentences, the word plant has been translated as pianta, and while in the second sentence, it has been translated as impianto. The multilingual context representation that we get is this one. This is obtained by merging the context representation in all different languages. So you can see that the word is translated in different way depending on the meanings. This can be very helpful for a word sense induction task. We executed experiments by taking by using JRC Acquis Corpus as a training set. It is a large collection of laws available in 22 different languages, and we considered it and extended it to reach more than 2 languages at a time. So we considered 5 languages and built all combination of languages, starting from 2 languages and up to 5 languages. The result can be seen in this graph, where we have that by increasing the number of languages, we are getting even better performance. The average performance gain from the single language setting and the 5 languages settings is about 5%. There are some gain peaks with some words that reach about 40%. Starting from these good results, we're starting to work to an application of this algorithm. We focused on the intelligent web search result clustering. That is the improvement of the fruition of of web search result by clustering this result by its similarity. The problem of today's web clustering engine is that they rely on a simple notion of textual similarity. They consider only the word in common between result snippet. So as you can see in the example, the first and third snippet is referring to the same tool, a Beagle search tool, but a web clustering probably will assign them to different cluster because they have no word in commons other than the search query. So the solution is to use a word sense induction algorithm in order to group search result depending on the meanings. Our proposal is to use our multilingual word sense induction algorithm, translate the query and translate the query and the snippet and apply the multilingual word sense induction algorithm. These are my publications. The first one is referred to the multilingual word sense induction algorithm. It has been accepted and presented on the Web Intelligent conference on August. And the second one is an article that we are writing and we are submitting to the Web Intelligent and Agent System journal that is focused on the application on intelligent web search of our algorithm. During this year, I worked also in on the field of schema matching, and by following the MOMIS approach. And in particular, I work on schema label normalization, that is the reduction of labels to a standardized form that can be easily annotated. I particularly work on a new version of the norms tool presented by an ex-PhD student, Serena Sorrentino, and I started to use this new tool to expand compound noun and abbreviation in order to improve the word sense induction performance. As future work, I would like to focus on the use of a big quantity of data, and so the exploration of techniques and tools for start working with big data. In particular, the Apache Spark platform and the Scala programming language, because I would like to give an answer to the question, how can big data affect natural language processing techniques? So that's it. Thank you for your attention.
Thanks for your talk. Any question about this topic? Okay, thanks again. So the next speaker is Mr. Cristian Catalano.
Good morning, my name is Cristian Catalano and I'm a PhD student. My tutor is Prof. Colaianni, and today I'm walking about automotive insecurity or in-vehicle system insecurity. So here I reported a simple index to this talk. And my focus is the next future automotive computer. And we analyzed the main security issues and based on security properties. And I report some example about my investigation. Next future automotive computer. In-vehicle system is rapidly changing, and in the next future automotive application will transform in-vehicle computer into an app automobile or app cars, like your mobile phone. This is the idea of the car makers. But in-vehicle system, the car makers want to transform the in-vehicle system in an open platform, programmable, and with a growing set of powerful embedded peripherals and communication device. They put in the automotive embedded system everything from USB port, Ethernet, Wi-Fi, Bluetooth, CAN bus, and so on. It remains an open question if new generation vehicle information platform will be secure too. And we analyzed the potential main security issue for the new generation vehicle system, and this investigation of the in-vehicle system security requirement was based on a number of key security properties. In information security, is common to satisfy these properties, in particular confidentiality, integrity, and availability of the data. And so we reported main security issues for a typical embedded system, automotive embedded system, and we investigate. Here I report just a short list, but I think in the future this list could be more greater than this. And for example, here I reported an example of the common issue. Usually the car makers want to realize a system where only authorized software must be accepted by the vehicles, but and no manipulator or malicious software must be downloaded to the vehicle system. But this is a critical point because it's not an easy solution. Usually a common solution is based on digital signatures, and where the car makers or a third part develop an application. This, the trust center of the car makers close this application with a secret key and store it in a database. And the in-vehicle system have to download the software and check it with a public key. But the problem is protecting the public key because if an adversary is able to read out or replace the key, he might be able to manipulate program or data code. So there are some solutions, but this solution usually is related to the hardware. Some companies like ARM developed a system called Trust Zone to protect the key, the public key. But this solution is very expensive and sometimes is not easy to implement. Another question is the CAN-bus communication, because the real problem is that car makers now want to mesh the old system, the old automotive system with the new generation systems. The idea is to realize an embedded system where entertainment and the control for the automotive is to unify these systems. But the old world, for example, with CAN-bus communication, is very difficult to integrate with the new world because, for example, CAN-bus has some weakness by design. It's very difficult to mesh this world. If, for example, a recent study identifies several successful attacks vector allowing full control of the automobile functions, and because a CAN packet usually does not include addresses in the traditional sense, and instead support a publish and subscribe communication model. So we can attack the system with the attack like DOS or packet sniffing or fuzzing or reverse engineering. And now there are not a countermeasure for this because because the problem is the design. We have a short time countermeasure could be to implement an EDS, but you can imagine that an EDS is very difficult to go on an embedded system. So actually, we automated the population main security issue for in-vehicle platform system. It was a long job, and we are working to propose a potential secure architecture to extend and leverage the security level of the next future in-vehicle systems. And we are working to propose a methodology for achieving a multi-level security known as defense in depth to defend the in-vehicle computer better than now. So, thank you.
Thank you. Any question? Just a question. Are you working in cooperation with any car company of this area?
Yes. I'm working with companies in Turin area, but I cannot report my job because I don't have the permission for that now.
But
so.
Does it involve the CAN?
Yeah. The big idea is to mesh the old world with the new world, to have just a computer on embedded on automotive. So this is less expensive than now, because now usually the new car have two systems: one to accelerating, one to control the CAN bus, yes, and another one for the entertainment. Yeah, but the new generation, yes, the new generation is to have a system where third-party companies can write applications and put these applications in the automotive, like your mobile phone, for example.
But is there any risk? I mean, it is, in my opinion, it is good for robustness and security to keep the unit handling the CAN bus separated from...
Yes, I know, but the trend is to have just a platform, because this platform is not so expensive. Just one yeah. For example, there are a lot of vulnerability. For example, they want RS-232 serial ports. It's very dangerous to have these ports, but they need these ports because it's easy to use for the shop car, and it is quite simple for the maintenance and so on.
Okay, thanks again. Okay. So the next speaker is Mr. Gian Pietro Di Tullio.
Good morning, my name is Gian Pietro Di Tullio, PhD student in the first year. My activity, okay. Again, allora, my activity is focused on the research and the development of biomedical devices using optoelectronic techniques. The interest stems from a remarkable increase of optoelectronic instrumentation in areas such as biochemistry, biophysics, and medical diagnostic, and from the basic idea on using the light as a non-invasive investigation tool. The measurement system by fluorescence light stand out among the optical techniques. This is a method already widely used in numerous applications, such as study interaction protein DNA, protein-protein interaction, making of immunoassay, biological analysis, fluorescence imaging, and contamination analysis. In this first year, I have been involved in making an optical device measuring the polarization of the fluorescence light coming from biological samples. This analysis generally requires quite expensive machinery, about tens of thousands of euros. Our proposed measurement system has, on the contrary, a low cost, about a few hundreds euros. The measurement system exploits the phenomena of fluorescence, namely is the property of certain substances, named fluorophores, to receive electromagnetic radiation. The measuring principle is based on the photoselective excitation of the molecular dipoles having the electric field aligned with the electric field of polarization excitation light. During the decay, the excited molecule can rotate essentially due to Brownian motions, thus presenting a depolarization which can be measured. Then, by measuring the polarization or anisotropy, we can get information on the molecular mobility. And for our measurements, we used as fluorophore the fluorescein in powder with the 10 nanomolar fluorescein concentration, because it's a typical value in biological applications. The measurement system has been adapted for the FTC, showing an excitation peak at 475 nanometer and an emission peak at 530 nanometer. For our test, the biological samples will be prepared using appropriate microwells formed by a matrix of the microtiter plate, as we can see in these pictures. And the measurement system can be divided in two functional blocks, the excitation block and the detection block. The first block is made up by a blue LED at an emission peak at 470 nanometer, and optical filter sent at 475 nanometer and linearly polarized. The second block, collecting the information, is made up by a linear polarized, mounted on DC motor, on DC rotating motor, an optical filter sent at 530 nanometer, and photomultiplier, providing an output voltage proportional to fluorescence light intensity. The signal from the PMT has been suitably filtered and amplified by a preamplifier stage and subsequently acquired by LabVIEW and Arduino card. Then, the development measurement system allows to analyze the degree of fluorescence polarization light from a solution. Besides, the ability to detect even small concentration of fluorophore make it suitable for biomedical application. During the test, we have found the presence of unwanted signals overlapping the fluorescence light, overlapping and altering slightly the values. We are working to reduce them, and the unwanted signals are primarily due to electromagnetic noise from DC motor, unfiltered light from the surrounding environment. Then the adoption of all possible measures to overcome these problems can be to equip the motor with a ferromagnet cage, to insert an appropriate optical filter in detection block, and a better insulation of the device from the environment. Therefore, my next research objectives will be to continue in the characterization of the optical device, to try improving it by extending its use to related areas, and more in general to implement new methods of measurement and to make innovation in field of biomedical device. Thank you for your attention.
Thank you. Any question? So we have the last speaker this morning, Martin Klapec, and then we will stop and we will restart at 2:30 p.m.
Okay, my name is Martin Klapec, and my tutor is Professor Maurizio Casoni. I will present now the work of my first year of PhD, which is based on the PPDR context, the public protection and disaster relief. The problem in this context is to be able to provide data-intensive communication in disaster scenarios. My work has been to give some answers to questions that actually are hindering the use of these kind of networks in after disaster scenarios. So, currently, problems of current solutions are the availability of terrestrial infrastructures, as when the disaster happens, usually these networks are disrupted or are unable to sustain the surge of network demand. The data rate, these networks are slow, and currently they offer only voice communication, but they're unable to offer data-intensive services. Resilience, for example, in certain kind of disasters as earthquakes, they happen one after the other, so networks are vulnerable to subsequent incidents. And the spectrum. Spectrum issues especially affect interoperability between countries. So, for example, if an earthquake or something like that happens in an area covered by different European nations, then there is problem for communication. So, the work was based on finding a solution to address all these issues contemporarily. So first of all, we want a network architecture that is accessible, which means that general user equipment as people's smartphones are able to access these networks. Then we want a network that offers coverage, like in, for example, in rural areas as well as in urban areas. We want this system to be fast, so to provide data-intensive communication. And we want this system to be interoperable, which means that it should be able to concurrently use terrestrial networks if they exist in the disaster area. So the main idea is to provide an incident area network through a mobile unit via LTE. This means that people would be able to connect to this network through LTE and to route data-intensive traffic through a new generation satellite backhaul. I say new generation satellite backhaul because classical solutions with satellites are only able to provide voice communication. So how to do that? Very briefly, with LTE, on the mobile unit we have to provide both the EUTRAN as well as the EPC modules. Why? Because normally an LTE antenna has only the EUTRAN subsystem. But without the EPC, we can't provide IP connectivity. So for example, in a terrestrial network, like EUTRAN and EPC are separated, and if, for example, the communication channel between them is damaged, IP communication cannot be guaranteed. This way, by embedding both subsystems on the same vehicle, for example, each vehicle is able to provide IP connectivity through the satellite. So in disaster scenarios, we have to guarantee also advanced voice services as those used now with current PPDR networks. For example, terminal-to-terminal communication and group calls. And this is possible using LTE from LTE release 12. Then we have, as already said, to guarantee broadband communications, especially for first responders, which are, for example, firemen or police, and also to provide at least basic communication services to people in distress that may be injured, for example, in the disaster area. And how to do this? The most efficient way is to use LTE bearers. A bearer is a defined IP flow that specifies a specific quality of service. For example, there exists guaranteed bitrate bearers that are suitable for voice over IP traffic that guarantee a certain bitrate, as well as best effort bearers that are suitable for concurrent file transfer, for example. So how to realize interoperability? This is a crucial feature of the architecture, and it makes use of LTE self-organizing network function. These functions, of course, reduce somehow let's say the spectrum of configuration options that can be leveraged, but they have the very important advantage that they are automatic. And this means that if in the disaster area, for example, the picture on the right, terrestrial-based systems are still operative, we can deploy MEOCs that are little trucks in the figures, and we can using, for example, the automatic neighbor relation function of LTE, make them attach automatically to the already existing network, and so extending the coverage of the existing network, and also providing increased data rate. On the contrary, if terrestrial networks are disrupted, with MEOC we can deploy a totally infrastructureless solution that is very useful for example, in rural areas or in areas where coverage is completely disrupted. So I will not go into details of this now for time constraints. This way, this architecture poses an a problem that must be addressed, and it is handover. Like usually, in terrestrial networks, the S1 connection is only used between APC and EU-TRAN. So between antennas, which is not showed in the picture, the X2 protocol is normally used. And the X2 protocol is the default handover protocol when, for example, a person with a smartphone passes through the coverage of one cellular node to another. In this case, we must use both X2 and S1 handovers, which are also procedures already contemplated in the LTE specification. But the important thing is that both these handover procedures are, from the point of view of the user equipment, are quite the same, and they are automatic and transparent. And this means that a person, being that a first responder or like people in distress, is able to shift between one cell and the other without having to configure his device. So specifically, we have to use X2 handover between terrestrial and node Bs and S1 handover in all the other cases. So this architecture also allows to deploy incident area networks that use the same specific frequency bands used in the area of the disaster. That is a feature that may at least ease the cross-border interoperability issue that I mentioned before. Then to conclude, like the features of this architecture, I just say that it also allows to provide indoor and internal coverage. So with what performance this architecture can guarantee? It actually reduces somehow the nominal capacity of LTE coverage. Why? Because in urban areas, for example, LTE as well as other cellular networks coverage is quite small because of a very high user density. And this is, for example, what happened yesterday in Paris. There were 2 million people in the same area and communication were completely blacked out. So like the bottleneck regarding coverage of this solution is the LTE part, while the satellite actually offers very good, very wide coverage. Same goes for LTE. I said before that we want to use new generation satellite system as medium Earth orbit system because they offer a very high bandwidth. The O3B solutions offer 1.2 gigabit seconds for each spot beam of each satellite. And they offer a very good latency, which is very important, especially for TCP connections. We made some simulations, and as a general estimation, we can say that with medium Earth orbit satellites, as O3B, we have around trip latency, so back and forth, of around 230 milliseconds, which allows us to use general TCP. So apart from propagation delay, there is also the problem of queuing delay when using TCP applications. And this is related to buffer bloat, to very high buffers that exist in the network. Moreover, in wireless system, channel conditions can change very rapidly. And we want to provide also a solution that addresses this issue. So my colleague has already presented this, so I'll skip it. We developed a dynamic bandwidth management algorithm to address the specific issue of dynamic bandwidth change with TCP. that uses channel state information. And what this algorithm does, it's starting from a centralized solution that can be employed on each of these MEOC. If, for example, one node is capable of using more bandwidth and one node is not, it automatically shifts network demands to the most appropriate channel. And these are the results. Without our solutions, with many nodes, the total throughput of communication is very variable, while with our solution, you can see it's almost optimal. The same goes for queue occupancy, that solves that queuing issues delay I was talking about before. As you can see, the green part is our solution, while the red one is the standard state of things. So also queues are kept very low, which is very important also for throughput. The same, of course, goes for the data transmitted, and you can see by the confrontation of these two pictures that our solution guarantees that the queue size is always kept very low. Okay. This architecture will be presented in the March issue of IEEE Communications magazine, so if you are interested, you can find more details there. Thank you for the attention.
So, thank you very much again. Any question? Okay, thanks for your talk again, and we stop now, and the last part of this day event will be will start in a couple of hours, say 2:30. Okay, thanks again for attending this event. This afternoon we have the last 6 presentations, and the first talk will be given by Mr. Marcello Missiroli.
Good afternoon. My name is Marcello Missiroli, and my tutor is Professor Michele Coleani. I would like to show you some results of my first year research, which focuses on the Internet of Things. The Internet of Things is usually defined as the interconnection of uniquely identifiable, possibly embedded devices via the Internet. There is no big consent on this definition. For example, Cisco and other companies prefer to use the Internet of Everything definition, which includes people, process, data, and things. The Internet of Things is now a hot topic. It is considered the next big thing in information technology. For example, the Gartner Group gave us this prediction that by 2020 we will have more than 30 billion interconnected devices. So there is obviously a lot of interest, both on the academical and industrial level. And the thing is, in fact, really complex. And I spent a lot of time looking around and searching both the research in the field. And as you can see, there is a lot of different issues: communication, power, big data, the cloud, and location-based services. Most of the research focus on communication and electronic systems. And privacy and security, on the other hand, seems to be a little not so covered. So I decided to look a little deeper on this subject, and I found 2 possible research field. The first is the IoT and the cloud. Usually, the Internet of Things is based on small object, embedded object, that have not the ability to store a large amount of data. So it is possible that they need to store a lot of data on the cloud. But this might have both security and privacy risks. For example, the cloud provider might not be entirely trusted. It might be honest but curious, meaning that it might look at the data which it has stored, or it might be even completely untrusted. Usually, standard security measures are really expensive because it requires a message authentication code that controls the entire data row, or in some cases, the single data that is stored in the database. So we decided to propose a trade-off solution, which is to use Bloom filters, in fact, encoded Bloom filters. The Bloom filters is very fast, is compact, and does not allow false negatives, meaning that if the value is not part of the data set, it will be detected. However, it allows a small percentage of false positives. So we define the definition of just enough security, which is by defining a acceptable false positive rate, for example, 1001, we might have a good trade-off between storage and security. For example, we used a standard TPCC database, and we tried to use this method both and confronted it with both the normal security measures. In the average scenario, which we found that the traffic reduction is is much lower, from 38% to 43%, and there is even more advantage in the storage requirements. And this was the first field. The second aspect is the location-based services, which is also very important at the moment because of many factors. For example, there is a lot of legislation in the world, starting from this January, for example. All new cars should include eCalls devices on cars. Insurance companies are very interested in tracking us and reduce, in tracking us. And traffic management, in addition, is very important, especially in Japan, where is a very important topic, remote diagnostic, and even anti-theft. This is the general idea, generalized idea of location-based services with respect of in the automotive scenario. We have a black box on the vehicle, which communicates via an communication infrastructure with various service providers. There are a lot of possible risks. For example, tampering with the device, eavesdropping. It is possible to listen to what actually is being said inside the car. If the software is not strong enough, there might be backdoors that might be exploited by hackers, and even more. The current situation is very complex because at the moment each service provider requires its own single proprietary box, and the user has essentially little or no control on his own data, and there's not much research on the field. So what we propose is a two-pronged solution, one regarding the embedded device on the car, and one on the web. The first we call the white box, which is a unified device for all services. It should should allow the inclusion of new services, new application, and it should be possible to be upgraded both on the software and on the hardware side. And it will be developed with an open approach that improves inspection, patching, audit, and with the security in the mind. That are essentially all the subsystems that compose the white box, which is essentially almost everything you might require. So the possible advantages are security management on a single device, lower costs because you only need one device, interoperability among different service providers, and control is left to the user or possibly a trusted third party. The second part, which is the open privacy broker, is centralized security, privacy conscious and security oriented service handled. Even that is developed with an open approach, and it will handle all the interaction from the white box to, or even a normal box, to the service providers, filtering and allowing only what is effectively needed for the given service. The current status of the research is that we have defined the white box architecture, and we are testing a software prototype. The broker is a little, not so developed. So to say, we defined the general algorithm, and we are defining the general software architecture. So there's still a lot to do. What I intend to look is the balancing the privacy versus accountability versus anonymity, which is a complicated thing, and to test the white box and the broker interaction. So thank you for your attention. That's all.
Thanks for your talk. Any question? So your interest at the moment is mainly on vehicular applications of IoT, not for home applications.
Well, at the moment, yes. It depends on what it turns out. For example, today I saw some interesting application that might be included for example, in the broker.
Okay, but no attempt to develop a sort of hardware demonstrator? No, only software?
Only software, yes.
Okay, thanks again. So the next speaker is Mr. Natale Patriciello.
Thank you so much. Okay, so in my first year of a PhD student, I developed a system, a modem to reduce latency in the satellite emergency network environment through a cooperative transmission control. A bit of overview, not in chronological order, but to give a linear presentation about the problem at the actual state of art. Then the environment, which I focused to my work, C²ML, which is the actual solution I developed, and some results in for both throughput and delay. And then I conclude for conclusion. And about the problem, I focused on the latency. what is latency? Latency is the time difference between the cause and effect. And today, everyone is interested about the throughput, the bandwidth, 7, 20, and nobody cares about the delay. So there are multiple sources of delay in an entire network. For example, the buffer along the entire data path, the retransmission in case of using TCP, and the situation is worse when you have to use high delay links like satellite, and specifically in the emergency networks where satellite is really used. Because you can have a problem with reliability, with actual and already developed solution like LTA station or whatever. Actually, for reducing latency, you can drop some packet in the queues, and the name is called active queue management. Or you can use various TCP variants like Nordwire, Cubic, or so on, with explicit congestion notification, and so notifying the endpoints about the congestion along the entire data path. But there are some weaknesses, like for example, in the case you drop, you have wasted something. You wasted one packet or more packet. You can't use many TCP variants for this situation, in this situation. Hopefully only one should be okay. And for using explicit congestion notification, you have to have stateful nodes along the entire data path, so modifying router, modifying endpoints. And so what we have buffer bloat in everyday networks and IG latencies in emergency networks that are not so. The environment which I focused is the typical emergency situation where some first responder talk with a mobile center, which through a satellite link connect to a base station and so to the internet. But the solution could be adapted also in everyday networks like home in the mountains, which is connected to the internet with a satellite link. Where there is a high delay link, the solution could be employed. A bit discussion about C²ML, which stands for congestion control. The overall idea is to cooperatively adjust the transmission rate. So, with some design principle, which we took seriously. So, we need only sender-side modification, and we require at most one standalone application on the gateway, which provides connectivity. And the solution should be independent from any AQM schemes. We divided the C²ML in two parts. The first is the layer C²L, congestion control layer, which we are using for the communication between gateway and nodes. Without, I don't have the pointer, but the only modification is in the local network and the sender side of the nodes. Remote network, remote nodes are not touched. And the protocol, C²LP protocol, which are a set of messages which are exchanged between nodes and the gateway. It's pretty simple. Nodes update gateway when they enter or leave the network, and the gateway transmits to each node actually present their allowed bandwidth. In this way, we can prove something, but we used NS3, which is a simulator, a very, very efficient simulator. But it was lacking in TCP protocols, so our solution could not be tested with all many and possible protocols. And so, it doesn't have in the past the TCP option, like window scaling or timestamp, which could in some way interfere with our simulation. So I sent a proposal to ESA in SOCIS, which is like a Google Summer of Code or something like that, to add some TCP variants like Cubic, BIC, HIBLA, XSpeed, and Nordic, and to write the support for the TCP option. There was over 90 proposal. Mine was accepted, and in the summer I coded all things and actually won the competition. So I can present here the results. For time constraint, I show only what happens with TCP Nordwijk, but with other TCP, the results are pretty the same. On the left, we have the situation before. So nodes are pretty fair between each one. On the right, we have the throughput with C²ML. We see that it could be, the throughput is still okay, and one could say, okay, but what is the really, really interesting result here is in the delay. Because we can see that, sorry, wrong slide. In the delay, we have on the left the queue used. We see in the red the Nordwijk alone, and in green with C²ML. It's logarithmic scale, so over 1 megabyte of data in the buffer. With our solution, we see we are pretty constant. And so the next question we have posed to ourselves was, but what happens if we, in the standard environment, reduce the buffer size? We can see on the left that TCP Nordwijk start to be not so. On the right, we see that with C²ML, the results are pretty the same. See the previous slide, for example. So to make a comparison, a fair comparison, we have used up to 16 nodes, and we still see the fairness with the James Fairness index was near 1, so the best results that we can obtain. While with Nordwijk alone, we are up to 0.4, so 0.3, not so good. And in conclusion, so we designed C²ML. We simulated C²ML in the emergency network environment with the help of the code I've written in the SOCIS, and reported throughput, fairness, and design. At this point, I can state that C²ML effectively improves performance, higher throughput, improve the fairness, and reduce latency at a cost to some sender-side modification and one application which runs on the gateway which provides connectivity. In the future, we want to improve the simulation efficiency with using 3 threads, with using NetMap for transferring data between each instance of the simulator, to virtualize different and complex networks up to 100 or 1,000 nodes and see what C²ML can do in this environment. A brief list of publication, journals, and conferences and workshop, but no, so thank you.
Thank you for your talk and congratulations for your result. Okay, any question? Okay, thank you again. So the next talk will be given by Mr. Fabio Pierazzi.
Hello, I'm Fabio Pierazzi, and I'm here to present the research activity of the first year of my PhD about security analytics. In particular, I have been working on two main topics, and I will start by presenting my work on adaptive encryption strategies. The context of the problem is about outsourcing data to cloud database services, and the problem is that a cloud provider may be interested in reading and accessing the data. So in order to protect data confidentiality, we have to encrypt it. But since we are in a cloud database environment, it is compulsory to execute operations even on encrypted data. Existing fully homomorphic encryption algorithms allow the execution of any computation on encrypted data, but are impractical because they require execution times that are too high. So in literature there have been proposed several SQL-aware encryption algorithms that allow to execute some specific operations. The problem that we are tackling is if we suppose that each column is encrypted with only one encryption algorithm at the same time, like for example a column encrypted with a deterministic algorithm that allows equality checks. What about if at runtime the workload changes and I want to execute another comparison operation? Our proposal is to the proposal of an adaptive encryption architecture for cloud database services that allows to execute new operations at runtime, and that's the important aspect of not requiring an intermediate trusted proxy that will limit the scalability and elasticity of the cloud service. The idea behind adaptive encryption schemes is that data is encapsulated into several layers of encryption. Outer layers allow less computation, but guarantee higher levels of data confidentiality. For example, all the external layers of these structures called onions are encrypted with a random encryption algorithm that allows no operation, but guarantees the highest level of data confidentiality. When a new operation is requested at runtime, the proposed architecture dynamically removes the outer layer of the onion that is capable to support the requested operation. For example, if an order comparison is requested, at runtime, the random decryption layer of the onion node is removed, so the order preserving encryption layer is exposed, and this operation can be executed. All this happens directly on the cloud database service through stored procedures, and the cloud provider never gets access to plain text data. We have evaluated the feasibility and the performance of the proposed architecture through the TPCC benchmark in an emulated cloud environment. With emulated clients and latencies. In particular, the results show that for realistic network latencies of about 40 to 60 milliseconds, the throughput, as the number of transactions committed per minute, is approximately comparable, because most of the overhead, most of the throughput slowdown is caused by network latencies that mask also part of the overhead of the encryption. We also proposed an original cost model for estimating the costs of the cloud database service, in particular for estimating also the usage estimation increments deriving from statically and adaptively encrypted cloud databases. And this cost estimation models also takes into account estimations over medium-long term by considering also reduction of cloud prices and also increments in the requirements of network and storage usage for the applications of the tenant. In the last month, I have also been working on the management of possibly huge volumes of security alerts. The problem is about the fact that the number of network attacks and alerts has been greatly increasing and is constantly increasing, but a manual inspection by human security analysts is still required. So several approaches have been proposed in literature, especially related to attribute-based correlation and multi-step attack detection. But however, little attention was devoted to the temporal characterization of these alerts. In particular, our proposal, the proposal that we are working on, is a methodology for investigating possibly huge volumes of security alerts to identify some stable or temporal characteristics. Our methodology begins with some preliminary analysis to determine some possible significant aggregation that are useful to extract information from the alert's numerosity. In this example, we have that most of the activity is generated by internal hosts during daytime and is related to the Trojan activity class of the SNOR taxonomy. Then we focus on the internal Trojan alerts, and we divide the dataset into 3 subsets in order to verify the stability of the properties, and we analyze the data distribution and the temporal dependence. The data distribution is analyzed by representing the box plots of the distribution of the number of alerts per hour during the different time slots of the day. And the temporal dependence is verified by applying the autocorrelation functions for up to 7 days, like the vertical dashed lines represent 24-hour shifts. And in this example, we can see that most of the activity is focused during daytime, and the order of magnitude of data distribution is preserved over time. And from the autocorrelation studies, it is possible to observe a strong 24-hour periodicity. The stable temporal properties can be adopted, for example, for anomaly detection purposes whenever the alerts time series goes over or under an expected box plot, or other applications such as time series prediction and state change detections. We are currently working on novel strategies for semi-automatic alert management, and we might also search for relations with respect to other data. This is a list of publications related to the first year of my PhD, both journals and conferences and workshops. Thank you for the attention.
Thanks a lot for your talk. Any question? Okay, congratulations for your work. Okay, the next speaker is Mr. Luca Puviani.
Good afternoon. My name is Luca Puviani, and my supervisor is Giorgio Vitetta, and my research focused on machine learning techniques applied to neuroscience. The presentation is structured as follows. We will start with research topics and motivation. Then we will talk about biological signals and data. We will discuss the methods, and finally results and conclusions. Okay, the research are focused on machine learning applied to neuroscience, in particular in different fields of neuroscience, such as medicine, neurology and neuropsychology, cognitive neuroscience, affective computing, neuroeconomics, which is the science which study the decision making and how the brain work when make decision making, entertainment also, and others. From a mathematical perspective, the purposes of my research are related to the developing of mathematical models, starting from data and automatic knowledge extraction using machine learning and artificial intelligence techniques. And in order to make prediction, forecasting related to medical diseases or seizures occurring, but also decisions and behavior in neuroeconomics and sociology in general. So, can proceed. The first application we will focus on is related to a medical disease, which is the epilepsy. In 2013, the Food and Drug Administration approved a medical device is known as a responsive neurostimulation device, which is a medical device implanted into the skulls of the epileptic patients in order to make seizure forecasting and prediction. Because in general, the epileptic patients for epileptic patients is very dangerous when epileptic seizure occur, because maybe if this seizure can occur during driving or swimming and so on, it could be very dangerous. So the forecasting is very important in order to increase the quality of the life of the epileptic patients. Also, this kind of device is able to make some electrical stimulation inside the brain in order to make some kind of inhibition of the epileptic seizure itself, and can make also drug delivery in order to try to avoid this epileptic seizure. Here just a picture in order to show how, for example, the medical equipment can implant it into the skulls of the patients. Here also we can see a figure of the matrix of electrodes planted into the brain. Also, a lot of experiments and data are available from animal models, such as dogs, because epileptic seizures are very common and very similar in dogs and humans. So also for our algorithms, we use both human and dogs intracranial EEG data. Here a picture to show the main brain states which can occur in an epileptic patient brain. We have an ictal state when epileptic seizure is occurring, and mainly we have a preictal state, which is the state that we have and the device has to forecast and predict, because when the brain is in the preictal state, within more or less 1 hour, it's very probable that epileptic seizure will occur. The interictal stage is a safe stage where no seizure will occur. So it's like a non-pathological patient. In general, this kind of signal, so the intracranial EEG signal and biological signal in general, are very nonlinear and non stationary. It is very difficult to acquire this kind of data, and nowadays we have a lot of internet portal and platform for data sharing for this kind of data from also a lot of hospital and so on. And so you use this kind of data set in order to carry on our research. Other kind of signal that we can use for this kind of purpose are, for example, skin conductance sensing, which is a biological measure related to the autonomic nervous sympathetic system. And also in the future we can use pupil diameter variation and other kind of measures such as vibration, accelerations, and so on. All from wearable instrumentation, low-cost wearable instrumentations. So use the data from International Epilepsy Electrophysiology Portal. where we can find signal from human and animal with a lot of different features, such as varying electron numbers, sampling frequency, and so on. In this way, we can have a deep understanding of the epileptic phenomenon, and with a lot of varying features such as frequency, electrodes, and other kind of signal properties in order to generalize well with the algorithm. Here, just an example of data set with just 1 hour of sampling with a matrix of 16 electrodes, for example. Here, magnification, just to magnification with 4 electrodes in 10 minutes of EEG signal, raw data. Another magnification, just to understand what kind of signal we focused on. Here, for example, 2 seconds of sampling from EEG signal. In general, okay, this kind of signal very nonlinear, strongly nonlinear and non-stationary. So we use the wavelength transform in order to extract feature and to signal processing techniques. And also we extract the chaos theory feature in order to face with this kind of biological signal. Here just an example with a wavelet transform using MATLAB, where we have the raw signal and below the absolute coefficient after the wavelet transform. Here we can see the first row, the raw signal, and then some scales after the wavelet transform. And so we can think the raw signal as a superposition of a lot of scales, a different scale after the wavelet transform. And we will extract a feature directly from these different scales that compose the signal. Our methods and our algorithm is a new concept, hierarchical algorithms based on hierarchical feature extraction and classification using machine learning techniques. We extracted features starting from a very slow time slot, starting from the full record of the data. Then, after the first classification of the time slot, we will pass in the second level, hierarchical level, in the full sequence of 10 minutes of recordings of EEG data, and then we will extract other features for the full matrix of electrodes, where we can take into account particular specific features such as the signal synchronizations, because it is known that when an epileptic seizure will occur, there is a very strong synchronization between the neurons. So this is a very strong feature in order to classify the brain state. So our results permit to obtain a very strong model for epileptic patients and epileptic seizure. Our hierarchical multi-structure modeling ensures flexibility, improved accuracy, and stability. Future research will be focused on not only intracranial signal, but also EEG signal, skin conductance measure, heart rate, and other kind of less invasive measures from the body, in order to better understand the brain and how we can model the brain and brain states, both in pathological and non-pathological people. Okay, thank you for your attention, and I am available for any clarification.
Thanks for your talk. Any question, curiosity, or?
Hi. Did you use linear SVM, kernel SVM? Which kind? Gaussian kernel or Gaussian kernel? Okay.
Okay, because using PCA before SVM, it mimics a kernel behavior. So you can stick with linear SVM in this case because non-linearities are in the PCA part. Okay, so you can try to do the same and just compare the result, in my experience. Okay.
Okay. No, yes, this is true, and we are evaluating. It is not. In fact, I don't report the final results because we are facing. And also we are thinking that for the future research we can use also deep learning concept. So directly use deep learning neural network in order to extract feature automatically, because for this study we extract feature in automatic way, but for example entropy from the signal, one feature is entropy, another feature maybe the wavelet synchronization and so on. So we are facing a lot of algorithms in order to understand which is could be the better for you know, high accuracy and so on.
Okay, thanks again. The next speaker is Mr. Francesco Solera.
Hi everyone, my name is Francesco Solera, and the research goal of my PhD is to explore new algorithms for enhancing the way machines can understand human behaviors. In the first year of my PhD, I've come across 3 problems which are strongly related to each other, and the first one is multi-target tracking, group detection, and leader identification, and each one of these problems builds up on the solution from the previous one. So, for example, group detection needs the trajectories that are extracted by the multi-target tracker to work, and the leader identification needs groups by the group detector. So, multi-target tracking by detection can be seen as the problem of following a multitude of people inside a crowd when only the detections of the people are available, and they probably are inaccurate. So the problem can be cast as an optimization problem in an offline fashion, where I have a set of detection from a set of frames, and I consider them all together to build the trajectories, or otherwise in an online fashion where I incrementally construct the trajectories by exploiting the trajectories that I know from the previous frame and the detection of the current frame. Offline methods tend to produce better results due to the larger amount of data that they can work with, but they're not suited for real-time application because they introduce a tracking delay, while online methods need to be careful about drifting. So state-of-the-art multi-target tracker, when online, usually just use distance and maybe motion prediction in the prediction step, because the other features that are more informative tend to be less reliable due to the confusion in a crowded scene. So we believe, nevertheless, that there are some cases in which features such as color or shape or maybe anyway more complex features could be useful to solve the correspondence problem between detection in consecutive frames. So the question is, when should we use these features? To answer this question, we study the way that we humans solve this problem, and we have studied that there are many cognitive theories that have been developed in the last decades, but the most influential one is called object files theory, and states that when an object is first perceived in the scene, it becomes bounded with a special index. So that means that an object is just identified by means of its position, as you can see in the right plot, while that spatial index becomes a pointer to the object's higher features, such as its motion, information, its appearance, and so on. This separation between what the objects are and where the objects are is also supported by the two-stream hypothesis from neurophysiological theories. Another important paradigm inside the object file theory, okay, it's interesting, is the spatiotemporal dominance, which states that no. Ah no, è proprio staccato qua. Sì, sì. Okay. The spatiotemporal dominance paradigm states that correspondence among detection in consecutive frames is made on the basis of spatial information only. So, to acknowledge that, I've put a strip on this slide, and the people that are pointing at Superman rapidly changed the perception of what they were seeing to the extent of giving it a completely different meaning and identity. You know, it's a bird, it's a plane, but they never had any doubt. They kept referring to the same object. So in this example, the continuity of the tracking was possible only thanks to the position. Of course, in real-world cases, when more than one object is present in the scene, spatial data may become ambiguous. And this ambiguity justifies the use of more complex features. So our algorithm learns automatically what ambiguity means for correspondence when only spatial information is employed in the resolution of the tracking, and how do we balance the contribution of different features, of the selected different features. We can do that thanks to a learning framework that is called latent structural SVM, which alternates the previously two mentioned learning tasks. So learning the ambiguity as latent variables and learning to predict the final output, that is the tracking. It is interesting to briefly describe the way that we computationally model the concept of ambiguity. And to see that, we first have to acknowledge that the online tracking can be seen as a correspondence problem, so it can be modeled as a minimum bipartite matching, where on one layer we have the trajectories at the previous frame, and the detection of the current frame are on the other layer, and the problem can be solved as founding the links that minimize the cost of the associations. The lack of local solution inside the final solution of the correspondence indicates the presence of ambiguity. We obtain state-of-the-art results on this problem, and particularly interesting, I want to show you the rightest column, where in green I have highlighted the correspondence that were solved by means of distance only, while in red the association that were found to be ambiguous and that we have solved by means of appearance and motion altogether with position. Once that we were able to extract trajectories from videos, we asked ourselves who was there together, who was walking together, who was standing together. So we wanted to find groups, social groups, people that know each other inside the crowd. And to answer this question, we cast the problem as a clustering or a partitioning problem of the crowd. And naturally, one can think that distance could be an effective measure to identify groups inside a crowd, but depending on the complexity of the scene, distance may not be enough. For example, when if you are observing a concert or a stadium where people are pushing around, a distance is not as meaningful as in other situations. So the question is, which other features should be used? And to answer this question, we borrow a social definition of group that you can read on the slide, and we handcrafted a set of features that somehow model the sociological intuition behind the definition of group. We used proxemics, DDAY, Granger causality, and heat maps as the underpinning methods of these features. So just to sum up, we have the trajectories, we run the multi-target tracker on the detections, we compute the pairwise features between trajectories, we train our structural SVM, and in the end we obtain the clustered pedestrians, so the social groups. In this problem we obtain state-of-the-art results as well, and of particular interest is the bar plot here on the left, where we can see how different features contributed in a different way in different videos. So that means that no simple rule could be just fixed and used to solve all the different scenarios. As a last problem, this is still an ongoing research, so we don't have formal theorems or results to show, but I just wanted to give you the intuition behind this. And it's the problem of leader identification. So given the groups of the crowd that we obtained from the previous step, which are the leader inside those groups? Which are those people that are leading the crowd? And we choose to tackle the problem by recognizing that leadership is a referential property of social relations and not hierarchical. And this setting is somehow similar to the way that Google rank pages. But on top of that, we are thinking of a learning framework, so in such a way that we are able to learn how to rank the pedestrian that refer to the leader in the training data. And this is showing some promising results for now, but as I said, we still don't have formal theorems. This is the list of my publication and videos of the results. Thanks.
Thanks for your talk. It's no, it is incredible to see how many details are extracted by image and complicated algorithms. So, is there any question about? Okay, thanks again. So the last speaker of this afternoon is Miss Patrizia Varini.
Pardon, I can't find my presentation. Oh, okay. Grazie. Good afternoon, everybody. My name is Patrizia Varini, and I present this project, which is called, referred to egocentric video summarization and processing, and it is related to project financed by Foundation Cassa di Risparmio of Modena, and some enterprises are involved in this project. The aim of this project is to construct an infrastructure which has the purpose to become a platform that is able to process and summarize and personalize user videos in a cultural experience scenario. And it can be considered an IoT project. In fact, the project aims to make use of a wearable camera board embedded in some wearable jacket or glasses, and it will talk co-op or HTTP, and a front end will be available in order to allow users to interact and upload and download their processed video, and they will be able also to express their preferences in order to extract from videos what features they will be interested in. Moreover, we will georeference subshot, of course, in a geographical context, but our aim would be also to reference them in a semantical map of concepts. Now we see how we plan to reach this goal. And this we present the pipeline and the tasks, the work packages of this project, which is only a little part of the project I presented before, which is called Vision for Augmented Experience. And this part is only related to back office, even if we have developed also a prototype for front office infrastructure in order to show the enterprises involved in the project what will the architecture be like. So pipeline tasks of our project are, of course, processing, video processing, which means that we rely on a visual feature to try to catch the base information about video, but moreover, we need to add semantic understanding in order to match what the user will be, of course, interested in. The final goal is to summarize videos uploaded by users and to personalize them according to some semantic set of interests which the user inputs. In general, summarization is related to, of course, obtain the same amount of information using a shorter document to store it. In our cases, summarization has some other specific issues because we work in an egocentric vision scenario, which has some further issues which are the jumping appearance of course, the images captured and the absence of hard cues between scenes, which makes particularly hard to understand the scenes which are captured in video. Of course, we plan to rely on visual features in order to process videos, but we would like also to rely on semantic information in order to add annotation and tags and to exploit the relations between the labels that we will find in video capturing. Our principles, of course, from state of art, which of course rely on frame analysis and subshot analysis at visual feature level, using of course the typical features used in computer vision, some as visual words, key point, GIST, histograms, and so on. And the classic pipeline is of course the one of identifying specific categories of objects and person, and to optimize diversity of information. We focusing on cultural experience scenario, we are interested in even little seconds of captured videos, because of course in an egocentric scenario with jumpy appearance of the captured video, it is very probable that we have a great amount of blurriness in video captured, and using an integral approach, it would be likely that you might lose some important information. So we rely on an approach, a differential approach on a very little number of frames, about 20 frames, which in a typical scenario which involves 25 frames per second means less than a second, which is anyway enough to show pattern behavior attention of the camera viewer. Of course, we plan to rely on some principles which are to pardon. I beg your pardon. I'm very well. What I wanted to say is that our approach, of course, has some kind of characteristic of what we find important, of course, to retain in our summarization issue. In particular, we are interested in extracting what has particularly interested the camera viewer, which in a cultural experience scenario we think is related to a steadiness state, so by a little movement of the head, and it must last at least 1 or 2 seconds, also according to neurophysiological studies which have showed that the minimum attention pattern is related to eye gaze, and so cannot be less than about 1 second. Moreover, we would like to maximize visual difference between subshots and scenes, and we would also like to capture what is important for the user which will request the summary from the platform. This means that different viewers may be interested in different things on the same video. So we think that it's correct to extract 2 different videos of summaries. This is the main approach we rely on. So the first task, which is visual processing, in order to try to understand the visual pattern attention of the camera viewer, relies on some features which we have in some way found also in literature, but we introduced some novelty, we think. We have used visual assessment of frames, blurriness in particular, computed as well, it doesn't matter, blurriness of frames computed in in 9 sections for each frame, and on optical flow, which is the apparent motion between frames, which we have calculated in 2 different approaches, dense and sparse approach. Moreover, we introduced the differential optical flow in order to understand a sort of apparent acceleration, which of course is only the parallel component of real acceleration, because the normal part of this vector is of course not accessible. In doing this, we extract features, pardon. Grazie. I beg your pardon. I continue. So we extract features from blurriness and optical flow computed in sections and quantized over 8 bins. And on this, well, we can add or not GPS coordinates at this level. It doesn't make a great difference. And we submit all these vectors, feature vectors, to multi-class linear SVM, which give us the subshot identified as those classified according classification which we have stated, which consists of 6 classes, and the most important are the pattern attention, which is related to more or less static behavior of the viewer, and head motion, which can be rolling or pitching head motion, and is typically associated with a change of user's attention. So the pattern identified by a static group of frames which lies between 2 head motion patterns typically show a change of user's attention, and is involved, we think, in capturing something which has captured the user camera wearer. In this way, we obtain anyway the classified georeference subshot which we are interested in, and from this we extract keyframes, 1 each 10 frames. In this way, in particular using dense optical flow, which has the least cost in terms of computation, we obtain in some way some results which we consider interesting. The second result is related to introduction of acceleration, of course apparent acceleration, and moreover we have added a hidden Markov model in order to reduce, of course, the variability due to the jumpy appearance of the video captured. And we think these results are useful for us. Now that we have extracted user pattern attention subshots, of course, we have a lot of information we don't need really, because many of these shots will be related anyway to some kind of not relevant information, or information to which the viewer is not interested in. So what we would like to do is to achieve some sort of user personalized summarization in which a viewer expresses his preferences in terms of concepts or in terms of visual forms. Of course, as Francesco said, tracking is quite a hard task. So in this work, we are going to limit it to input text, pardon. And our hypothesis is that user interest is expressed and composed of groups of keywords which, of course, are related to one or more concepts. And, of course, we know that also understanding keywords, or better, making researches using keywords is a hard matter because there are a lot of ambiguities also in text. So we want, of course, to obtain different summaries, but, of course, we want to obtain reliable informations by our expressed preferences. So here, of course, one has a choice because one can rely on fixed data set in order to use sample for training and learn, of course, to classify his data, his keyframes, and extract the most interesting information for the viewer, or use the information stored on multimedia social repositories available on the web. We chose, this is of course our choice. We work in the hypothesis to leverage knowledge extracted from repositories on the web, multimedia repositories. So our problem becomes to extract from web the most reliable training samples, positive and negative, in order to use them with supervised machine learning. We go on using linear SVM, and we have, in some way, we would like to present this approach which relies on leveraging semantic relatedness of concepts in order to reject information which is not relevant for what the user expressed as preferences. In doing this, we plan to use the knowledge stored in a semantic network. In particular, we used it with DBpedia because its content is updated in real time and is quite reliable. We have also GPS, so we can use also georeferenced data in Wikipedia. And our approach is to extract, so from user input keywords, clouds of concepts which in some ways contain information which can be useful in order to select or reject the sample that we extract from the web. DBpedia, of course, is can be seen as a undirected graph, and we have imported it into GraphDB, in particular Neo4j, where nodes correspond, of course, to concepts and edges to relations. Well, our expectations were that DBpedia was composed of a great number of small concept communities. On the other hand, we have found that it contains very few very large communities, so we had to use a recursive approach to find minimal tightly related concepts. In this way, we think that we might have some success probability to reject samples which are not so relevant in order to match the user preference. suppose, for example, that the user is interested in Romanesque in Modena. Of course, you will obtain from a Google research also results which, from a visual point of view, of course, we must rely on visual features when we classify images and keyframes, are not reliable because from a visual point of view, even if they are related to the concepts which the user has expressed, they will label. We found that in the major part, in the almost total part of cases, they were related also to concepts which are very far from the concepts, the cloud concepts, near to the user expressed preference. So these images can be rejected. This can be computed by a calculation of shortest path on the DB graph, which, for example, Digistra algorithm, and also PageRank can be used in order to make us understand if our interpretation is correct, has some kind of match on the web. Of course, if we reject images which contain labels which refer to concepts that are not included in the user preference cloud, we obtain much more reliable results from a visual point of view. And in fact, also results will show that we have much better classification scores. Measuring the relatedness of concepts on Wikipedia or in general on a semantic network may be quite a hard task. We chose to use a Girvan-Newman algorithm, which is not the most precise algorithm, but has a cost which is acceptable, we think, and in some cycles it can be able to find the most tightly communities of Wikipedia. And once we have extracted the samples, of course, which we can use a classical approach for classification, like a bag of visual words, or a Fisher vector approach. We have used them both, and we have discovered that the second one is quite better. We have also used 3,000 visual words, so greater number of visual words. And we see, anyway, that if we compare results of bag of visual words without semantic expansion, with semantic expansion, and the feature vector with semantic expansion, we find that the last method achieves the best result. Now that we have classified our keyframes, we, of course, we must select shots, because we expect that maybe more than one shot will be classified according to some preference of user. So we would like to rely on information difference in order to minimize the quantity of information we are going to extract without losing anyway relevant information. And this is done using GIS descriptors and scoring then their diversity with the expressed formula. And on the end, we have to score also the importance of the subshots, measuring their distance from the concepts which are relevant for the user. In this way, we are able to score, and according to this equation, which we showed at the beginning, we are able to score the final chain of shots, and which, of course, should be the optimal chain of shots. So I think this is the conclusion. We have introduced as novelties two things. Use the apparent acceleration in optical flow, which in any way refines the classification of motion attention pattern subshots, and the semantic expansion, which has proved to be useful when extracting samples for positive and negative samples for supervised classification of keyframes. Thank you very much.
Thank you very much for your talk. Any question? Okay, thanks again. So this event is over. Thanks a lot for your presence. Thanks for attending this event, and have a good afternoon.